allows me to dual cast to both platforms at once, which I'm technically allowed to do, but I'm not allowed to put YouTube chat on screen, or else I am apparently robbing Twitch. Okay, there we go. So now we are on YouTube. So now what I need to do is I need to go to my general browser window with my general account on it, and I need to come over here, and I need to go to YouTube, Oh Bother VOD. I am my biggest fan. I'm the only one that consistently watches my own streams. And then I need to go to chat and I need to pop it out. And now I have violated the YouTube toss that isn't really very explicitly stated. Instead, you just kind of run into it. It's like a really obscure rule that you shouldn't have both chats on screen at once. It's like the dumbest rule I've ever heard in my entire life. It is very cowardly. Very cowardly. But here we are. The YouTube channel is so unpopular, I can't do anything about it. I can't monetize it or anything like that. All it is another way to reach out to you guys. I could also stream to like Kick and a bunch of other platforms, but I don't know if my content will find such a niche. Twitch is the big one, right? Twitch is the big one, and it has all the people potentially watching somebody do tech. YouTube should be like that. I haven't found it. I guess streams and tech aren't as popular, but man, I could make a pretty penny, like a really nice looking penny, if I could get people to actually watch my my science and engineering streams. If I could get 1 million views, who the hell knows how that would ever happen? Maybe if I like get arrested or something, I would get 1 million views somehow from all the press. But if I could do that, I could make a significant amount of money because tech gets more money than like gaming content. It's weird. It's crazy that it does, but I guess they just want that kind of content, and that kind of content costs money. Whew, how's everybody doing, man? How y'all been? You look kind of raggedy right now, chat. You doing okay? You drinking water? How's your mother doing? I'm out here. We still have just inundated with family visiting and stuff. I've had multiple people here like just out of the blue, and just craziness. So I've locked myself in the basement so that I could actually do my job and actually stream for you guys. And I'm really excited to get this thing actually like hovering stuff, because we know it works. I just need to kind of retool the hardware just a little bit to get it to work again. We ran into ups and downs and all the usual programming nonsense that we do when we do things with Arduinos. My uncle was here and he was talking about AI and how the genie's out of the bottle, and how I could utilize AI in this stream. And I guess, you know, like I guess, but I don't feel like babysitting it through and through. And it has been a while since we have tried anything with AI. So it stands to reason that we might go back and attempt to like use it for something. Because it's there. It will always exist. We need to learn to utilize it at some point. All of the hours that we spent yesterday on code may or may not have been able to be streamlined through AI. I hate to say that, but this is one of those things where like I can refuse to use the personal PC because it's invaded every part of our lives, or I can get with the program, right? Right? It's one of those. It's like a watershed. I just don't know what's going to happen. It's crazy the way that it's sort of pervasive in modern society. And our power grid is not ready for all the data centers that are being pushed due to AI. It's like, yeah, let's hey AI, can you write this email for me for the cost of like a natural waterfall? Like just ruin one natural waterfall gets filled with trash when you hit enter on that AI prompt. One dolphin gets hit in the face with a car battery every time I ask it to rewrite an email. Just a little bit of battery acid in the ocean for every prompt that you run. Just a little battery acid as a treat. It is depressing, isn't it? We're not going to get depressed, though. We're going to work today. We got work to do today. We probably don't need the scope on the screen right now. So let's get the scope out of here. I want to drop that shadow a little further on the scope, actually. I want to make that a little bit more prominent. So the shadow, I'm going to distance it a little bit more. Just like a big shadow, so it looks like it's sitting right above. That's a little, we'll bring it in a little, And the intensity goes up a little bit. And I'd like the diffusion to be a bit more though. Filter type, color. That's source filter, yeah, just color. And then, what does that do? It's max threshold. I don't even know what that's doing. Blur type, triangular, yeah, that's fine. Padding, what if I do auto? Oh no, no padding. No padding is where it moves it on the screen, so there's room for, like your scene would have it maximized, and then there would be room for the shadow, so you need to pad it a little bit. And not much I can do with that. Okay, that's fine. What's up, Walrus? How you doing? Walrus. I was looking at my area on W Place. That was kind of fun. There's some cursed stuff going up nearby. In North Philly, there's a Peter Griffin head that's looking a little bit phallic. All right, let's turn this thing off. This thing is the scope. Frameless scope. I need to fix my buttons, my Stream Deck buttons for turning on and off stuff on screen, because it should be snappy. I should be able to like pop things up on screen really quick. And I have the capability of programming that. It's just a pain in the butt to go in there and mess with it all. Yeah, we're gonna float stuff in the air today, and I'm gonna get ferrules on this thing so that they survive a little bit better, all the shenanigans. And then we're gonna retool this circuit board a little bit so that we can actually run their code as opposed to what I wanted to do, because my stuff was a little bit jittery, and this garners a test. We're gonna have to test it. Ayademi, how many months was that? What did you do? What did you do? 12 months. Ayademi, thank you so much for subbing. That is very kind, very, very kind. Yeah, we got work to do today, but we got good work to do today, and hopefully at the end of things, we'll have something to show for it. I'm just gonna wire the laser either up to its own switch. Yeah, probably just to its own switch instead of a digital button. I wanted to have digital control of all this stuff, but I've gotta set my expectations now that I didn't meet them with our initial code. Kind of crazy that the sync would be off like that. I wonder what I can do behind the scenes to kind of synchronize the square waves to prioritize their accuracy instead of their frequency. Because the microcontroller has to do other stuff. It has to check the buttons and, you know, update some registers and do all that stuff, as opposed to the other code directly editing registers and using the timers on a lower level. Ours has to do other stuff, and then there's a time penalty to it. And so the time penalty means that it won't take precedent for the changing of the register doesn't take precedent over checking something else, and that's where that jitter comes in. That's when it doesn't respond as quickly as it could to lower that voltage level. One of the things of using microcontrollers, if we had multiple threads or if we had a faster microcontroller, this wouldn't be as much of a thing. And if I was using a Teensy, I could use the Teensy audio engine stuff that I think uses wavetables in order to prevent that sort of thing, that sacrifice. But timing is timing is timing. Let's see, I guess I could probably plug this thing in order to get just something on screen, right? Oh my God, why are we running up and down the stairs? People are doing, oh my God, what was that? Fatanon with a tier 3. Thank you for subbing. I will not be doing that, and I will also not be saying that because for some reason I'm cohabiting my space right now. 77 months, are you kidding me? That's insane. People going up and down the stairs, which are right outside the wall of the shop. Yeah, 77 months is a significant amount of time. That has always been a tier that you're not need to contribute that much to this stream, but I thank you for it. I thank you deeply from the bottom of my heart. And I know I say that in a silly way, but I actually do mean it. It's just I'm saying it in a silly way in order to remain guarded about my emotions. Stiff upper lip, no emotions. Good, good. Cheerio. On we go. So check out what my code did. This is my code. And those are supposed to be off by five microseconds, right? This is 40 kilohertz coming out of the Arduino. And there's jitter because the Arduino is using normal Arduino code. Yeah, straight face, stiff upper lip, no emotions. Let's keep it on the level. Remember, we are a stream. Fun is not supposed to be had. Your display is astigmatism. It's a little crazy. I added kind of a strong shadow to it. But yeah, so the jitter is because the microcontroller has to do other stuff other than manipulate the wave. And the PhD code, the actual real code, is like in lockstep. It's super duper duper good at its job. It's in complete lockstep for the square waves. Now the question that I have is, can we run this code and will it work in the levitator? So what we need to do is retool the hardware a little bit so the old code works with the hardware, and I'll put the laser on a switch. I'll have two switches up top here. And then we'll run that and see what happens versus the other code. And then this thing can sit on a shelf and come out next time I need viewers. Because I need stuff that's flashy and cool looking. So we'll shelve this old project. I can work on LED stuff, which will then benefit Burn the Subs, of course, because that'll Burn the Subs has an LED panel on the front, and I want that to be a little bit functional. And I would also like to put some LEDs up over there that'll just be kind of display stuff. You know, hook a Raspberry Pi up with a bit of Python and somebody else's code, and then we get some kind of a neat looking LED display. I would like to use what is it called? I forgot the name. I just forgot the name. Wait. Well, I forget what they call it now. It's whatever became of Milk Drop, the Winamp plugins, still exists. It's in sort of a prototypey kind of state. But if we can get either something running ArtNet or just not even ArtNet, just something that's inherent to a Raspberry Pi controlling LEDs in a grid, and we can somehow use those Milk Drop plugins in order to get RGB values, basically, of those LEDs, we can make something that'll play Milk Drop plugins. And those Milk Drop plugins, you can use plugins that have sort of contrasty things going on. There was one that had kind of like a white line that would get influenced by the audio in sort of a red background. And with far-spaced LEDs, if you choose the right plugins, you have some really good-looking visualizations that actually have some life to them. They actually have life to them. That's the important part, is that when you look at it, you know, when you trip it out and you're looking at the LEDs changing color, it's not just like randomly informed. You can see motion in some of the aspects, and motion, color variation, and sort of a unified design to the visuals that you're looking at. And I want that. I want that in a wall display. And maybe I can plug it into like a weather sensing thing, and it can also do, because that's using Touch Designer. A friend of mine in Philadelphia built this wall, and it's a wall that's sort of a stylistic display of America, and it has distinct LED like lamps behind it. They're like the size of light bulbs behind the America panel, behind and sort of through, because there's some cutouts and stuff like that. And so what they were able to do is use Touch Designer to do a weather, like an image of weather, and then stylize it so that they can see like, oh, there's red over there. There's a storm in Utah right now. It's pretty cool. But that would be kind of a neat thing to do with my wall. Be a lot to figure out. I mean, there's a lot of project in there, but that's something that I'd like to, you know, kind of get going. Oh, did we hype train success, meaning that we couldn't sustain it any more than level 1? Well, Burn the Subs, get that working again, get on the front page day 1 on Burn the Subs, and then we'll get an influx of like 100 people probably. And then maybe we can hold on to some of them for a little bit until they finally kind of wriggle free of my stream and go, wait a minute, you're really boring, get off of me. And then I will drop back down to having 20 users. What is that emote? Is that a mudkip? Frog Ponder. That's the wrong frog. Oh, they credit the artist. That's nice. Sharp balloons. I don't want a sharp balloon. Balloons are supposed to be soft. But yeah, that's the idea. As we move through these projects, we're kind of, you know, getting stuff that's visual and also working on Burn the Subs at the same time. This one's sort of an individual project that just kind of came up because I was cleaning up. But I have quite a few gift subs queued up for BTS. So for BTS, I want to do the LED thing that handles the front display of Burn the Subs so that we know kind of what Python we can run on that front panel, and it'll look a little bit fancier. And then I move the cameras over there. We need to strip all the wiring off of the board right now, and I need to redo all of the wiring. And it's going to be more simple because there's no limit switches. From there, I still need to get inside of Burn the Subs and do all of the crimped connections and the power connections and get all of that working with or without status lights. I don't know what I'm going to do right now. I would like to get the status lights running. I just don't want to be too underwater in terms of what tasks need to be done. But we need to go sit over there on the table and do some wiring. So that'll be a fun little thing. And then we'll know what the pinout of the DB connector is, and then I'll be able to wire the rest of Burn the Subs. We can set up a bench test with a couple of the motors or extra motors that I have, and try to get, in terms of what we want to do right now, it's either the updated Gerbil or I run something like Clipper, because Clipper just has that very simple front panel where I put in all the parameters and everything just works. And then we need to figure out what the API is to get into Gerbil. No, to get into Kerbal Space Program. No, to get into Clipper. What the API is in order to send M language into the software to get it to run the process of burning a name. So it needs to be Clipper in laser mode, and Clipper has all of that look-ahead momentum stuff that we need. I need to get it to TTL to the laser so that it can back off the laser during the fast linear moves. Or no, yeah, back off during the corners, increase during the linear moves. Not increase. Everything is backing off. Back off more for corners, back off less for linear moves. There we go. But yeah, and then, so we need to make sure all those features are in there. I think that might be trivial. I think we might be able to get that running pretty quickly once we get it all wired. And once I get all that done, we need to pull the pieces out of the brain of the software that I made previously for Burn the Subs and have that work with MQTT. So instead of polling Twitch, it'll simply get a request from MQTT to say, hey, here's the name that you should burn. And then the question from there is, should I have the database? It's going to be real slow if I do that. No, that can't be. The database has to be local on the Raspberry Pi, because the Raspberry Pi needs to pull up a virtual image of Burn the Subs. And I can't do that in Node-RED. Technically, I could. Technically, I could do all of the Python business of Burn the Subs. I could bring over to Node-RED. Can I run like... this is going to be weird. Where's the window? There it is. Node-RED Python. The conversation was whether or not I should be using AI, and it's like, it is the genie out of the bottle kind of thing, but every time I see an AI answer like this in relation to the electrical engineering stuff, not necessarily the coding, because I might actually understand the coding a lot better. When I see it in relation to my electrical engineering questions, it's always wrong. It's always wrong. Calling Python script from Node-RED. So you can do it. An exe node. So here's the deal. So the Raspberry Pi is only so capable, right? And the Raspberry Pi was pretty good at running Python. When I just ask it to do research for stuff like that for me, or analyze data, it does a decent job if you're very specific about the prompt. I see. It's all about making sure you're very specific. You know, and that the thing is, like, originally when we did our AI stream, what was it, more than a year ago? So, you know, obviously the whole landscape has changed since then. But when we did our stream so long ago, and I was asking it about like, hey, I need code for a Noritake e-tron screen in order to make it display a corgi. And it was like, wow, that was a very specific question. Like, why are you specific shaming me? That's what you need. It should be congratulating me for being so specific. But it's like, wow, that's so specific. I'm like, you snarky little AI bastard. So I can't actually run Python. So this is tempting. This is tempting because with Node-RED running Python, what I can do is offload the computational task of figuring out where names are, scaling and producing M code to the file server. And that way the database is stored on something with terabytes of information that's backed up, right? That I'm monitoring to see if anything goes wrong instead of an SD card that might fail. And that way the Raspberry Pi will run the business of MQTT and monitoring for a chunk of G code to come its way, and then it'll just execute the G code. I like that. I like that idea. Remember back in the early 2000s, you had to specifically craft your research terms to get what you want. You do that again. Yeah, that's the thing. Like early 2000s researching on the internet was so much different. I used to do a lot of datasheet spelunking back in the day. Back in the earlier 2000s, I used to do a lot of datasheet printing because I'd have to print out the datasheet and then go to class, and then in class I'd read the datasheet and like figure out what a chip did and how to use it and all that stuff. I didn't know too many project blogs back then. Look at how jittery my code is. God. Oops, wrong button. Wanted this button. Let's bring you back down. Jitter, jitter, jitter. Yeah, so that's where we are with Burn Them Subs. There's a lot to do. A lot to do still. I want to solve this LED thing, and then I can get back to wiring up all the stuff. I want to know that the things that I'm using are capable of doing the things that I want. It almost seems like, you know, I don't really need... Well, no, I need the Raspberry Pi for Clipper, so that's justifying the Raspberry Pi. Crazy how that is, though. The amount of processing on the board itself can be severely reduced. And I think I like that. I think I like leaving it to Node-RED because Node-RED has an entire like computer processor to utilize to run Python. It'll run faster, it'll run better, and the database will have more room to breathe that way. So we'll have it generate the G code in a Python program that runs in Node-RED. I'm gonna burp. Okay, I burped. I burped and my dog started barking. She's outside right now. I miss the days of there being just an HTML web page with all the information that you could possibly ever want on it, where it was like academics that were typing up their little HTML web page that they maintained. I'm on a web ring. Let me just post this extremely advanced information. That was the day, huh? It's a rare case that you would find that back in the day, but when you did, you knew something good was going on. Technically, I could drop a shadow on the overlays. Let's do that. I'm going to drop a shadow on that. I guess I would have to do it per scene. Let's put a shadow on that. Drop shadow. Click OK. See, now everything on that scene is going to have a shadow. I'm just going to leave it at default settings. Oh, that should actually be the first. It's a lot. It's a lot. It goes behind Streamlabs. There we go. Oh, Streamlabs also needs one too. Properties. I don't cancel. Filters. I'm abusing the shadows. I probably shouldn't do that. All right, so now everything has shadows on it. Overuse of shadow filtering. If it makes it look better, I gotta use it. how is everybody else doing? What are we going up against here? Project 450? No, that's a laser thing. Got Big John stream there. I've got a laser diode. I've got a 5-volt source. I got everything I need in life. I'm liable to just start any minute now. Feeling it. And there are people like right outside the window, so I'm going to be talking a little bit quieter. Not going to be emoting as much, especially as when I'm home alone, and I can actually like scream at the furniture, which is basically what streaming is. It's me screaming at the furniture for a bunch of hours. But we got enough work to do here, so let's actually start the stream. I'm actually going to get started. I'm feeling the existential dread of the lack of viewers on a Friday, and so I'm going to lower the audio here. I'm going to hit pause on it in case I take a break, and I am going to then what was I going to do? Oh yeah, turn off start soon, and let's get started. Hi, how's everybody doing? How you doing? Hey, it's me. There are people like right outside the window that can probably hear me, so I am not going to be as loud today. I will be somewhat muted until they move on to other pastures. But we have a bunch of work to do. We have hot gluing to do, we have hardware to do, and we have coding to do. I was looking at my wrong hand. I'm looking at basically looking at myself up on this monitor right here to make sure that I'm presentable, so that my hair doesn't do this in the middle of when I'm talking and I look silly. And so as I'm looking at myself, sort of peering in the corner of my eye, looking at myself, I'm looking at myself counting things like this, but I'm looking at this finger and expecting there to be more of my digits sticking up. Welcome to the mind of oh bother. Anyway, yeah, so we've got hardware and software to do. My software works. It works. It works perfectly. There's no problems with it at all whatsoever. It works. Except that you can see in the scope that it is a little bit jittery. It jitters. Jitter, what is jitter? Jitter is when you have an inconsistency in something like a square wave. So if you have like a clock signal and it has jitter, that means that it's getting off of specifications. It means it drifts in either direction, right? This is drifting mostly in the direction of the waveform being too long, which may not be an issue considering the system that we're putting it into, or it could be a huge issue if this is like a radio signal of some kind, right? It depends on your application, and in this application, the jitter is coming from the microcontroller having stuff to do. It has other stuff to do as it sort of goes through its tasks. The microcontroller has one thread. It performs instructions one at a time, depending on how our IDE deciphers what we've told it to do. We tell the IDE, I would like this to be a for loop, and it goes, oh, so that's a move LW, move this bit thing to this place, put this in the math processor, take this over here. It's like a totally alien landscape when you do machine language level programming. The IDE saves us from that, but at the same time, we're not taking direct control over the microcontroller. So as I have told it to note player 0 begin, it does stuff with the registers in order to create that square wave, but then it comes down here and it says, wait, I need to update the bouncers. So I need to look at the buttons registers to see whether or not anything's been pressed. And it may do these routines over and over and over again. Microcontroller doesn't have hardware PWM. It does, but it's, well, I guess this thing is taking it over. So our tone playing plugin is not using hardware PWM because we've got it hooked up to pins that don't support hardware PWM. So if we had it on hardware PWM, that might get rid of the jitter. However, in order to get around that, and the same pins that are being used by the, here, let's open up, hold on, open up this one. The real code, the good code, the one that the PhD students put together for the paper on the levitating thing, that code uses the machine instructions in order to, I don't know if they're utilizing hardware PWM, but they are lightening up the computational like overhead of their microcontroller code, and as such, it cleans up those square waves massively. The Arduino is struggling to open the software right now. You just have to give it a minute to think about what it's doing. It's an old program. It'll get there. It'll get there. It'll get there. Rest assured that, okay, what's going on? This thing isn't opening the program. Oh, it was already open. Here it is. It didn't even tell me. So yeah, this is the good code from the PhDs with no comments in it. Love uncommented code. It's great. It really helps you not be able to learn anything that's going on. But it's using all of these weird like ASM, NOPs, and weird DDRC, port Cs. We've gone into that kind of stuff before with microcontroller code when we're kind of like backed into a corner. See, they have fast PWM, clear OC1B on compare. It's crazy code. It's light though. There's not a lot going on. Not a lot for the microcontroller to be cycling through. I was hoping, however, to use just like a tone library and simplify this thing so that it's easy to read and easy to use, and I can just put everything together and have it work. That may not be the case. That may not be proper. That may not be possible because of the jitter that we're getting with running just 2 channels. We'll need to modify this code to do 4 channels of the square waves, and we'll see whether or not that can actually affect any sort of function out of this. It would have been nice if there were logic level things, because there were like some of these microcontrollers now, they have sort of FPGA style elements to them, and we could really use that like logic gate element in order to create the 4 signals that we need. We could take a square wave, invert it, and that would create 2 of the signals, and then the other 2 we could give it a little bit of a phase delay and then do the same thing with the logic, and it wouldn't have a lot of computational overhead, and they would all source from the same square wave. That would be nice, but I don't think that's what's going on with the tone plugin. It's possible we could find another plugin. These guys here, I believe, are doing something with wavetables. They have kind of like an animation here, and I don't know what this is all about. It's just like 999555666. What is that all about? What is that? I don't know. Like 0x6, 0x5. It's hex 5? Is that? I don't know. And it's somehow being used in the wide magical world of matrices in order to do something with registers. I don't know what. It's crazy. It's totally crazy. Maybe we can look up a different square wave library at some point. But right now, I kind of want to just get this thing working. So I am going to kowtow to this code, and I am going to rewire our circuit board so that it works with this stuff. So the buttons that we need are described in the instructables. That's tone library. This is what we're following here. So I need to wire this up exactly, and we will put one switch on the controller, and we will put another switch for the laser. So first, we're going to need some switches. Let's find some switches. And you can see this is my code. It's very jittery. It is very jitter. Once we get the hardware set up, we can then cross-compare the two. But let's find a switch. This is the fun part. We get to find a single pole, probably single throw switch. We don't need dual throw, but we'll probably end up with one. And I've got a couple different stashes of switches. One is for synthesizers, and the other one is just regular old scrap switches that we've found along the way. All the friends that we've made along the way. And we'll have to rip up a little bit of the circuit in order to get that. Make room for the new stuff. Oops, that's Streamlabs. I want the scope gone. I want the scope gone. I want it gone. I want it out of here. We'll just stuff that in the corner. All right, yeah, let's take a look. We're going to find a switch. It would be nice if I had 2 just little rocker switches, but I don't know what happened to all of my rocker switches. I used to have some. I don't got none. No, there's nothing in here. This is all huge. I don't need a giant. This is going to take up the entire thing. Why do I even have this stuff? Yeah, my buddy bought a switch pack from SparkFun, and I think this is what happened to it in the end. He needed like 1 switch, so he bought this entire pack of switches. I should buy like a little switch variety pack, like one of these things, but for switches. We don't use them that much though. I do have a couple like really tiny micro switches, but I don't think we need those. I mean, I guess I could do one of these, and then it could be on or on with laser. That doesn't really make much sense though. Or just two of these, on and then laser on off. On off and laser on off, and they can just stick up into the air. And I'll be right next to each other, so I won't be able to I won't be able to thread bolts on either one. I guess we'll do that. With the two of them side by side, they should support one another, so then you have these big clunky switches on the top of your project. It'll keep me from stacking stuff on top of this thing when all is said and done. Because remember, nature abhors an open surface. A clean open surface in a shop is an oxymoron. All right, so I'm going to get all this stuff off of the switch because it's not necessary. This is going to have all of the hallmarks of just, you know, your slapdash kind of little shop kind of project. And we'll get to soldering. People like to watch soldering, right? That's why y'all are here. Bum 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 bum. Let me see here. Let's think about this. I guess I'm just gonna have to work on it locally to here, so I'll just flip it over and work on the stands already, which means this needs to be moved out of the way of the microscope. And I'll keep it running that square wave just so I have something that I can put on screen if I really need to. It looks a little bit more like I'm doing smart guy stuff if all of these blinking lights are going off at the same time, right? And then let's get this stuff out of here and let's desolder the power area for this whole circuit, which is an unfortunate thing that has to happen again. There goes the dog. You guys can probably hear that. Question is, can you see the dog in the... Oh, she's already moved on. No, you can't see the dog in the window. That dog will bark at anything. All right, let's get into it. Maybe I can use my new tweezers. I bought some tweezers that can do wire stripping in the way that I need them to. So what do I need to undo here in order to enable some giant switches to get into here? Oh my God, it's a complete mess. Let's see here. So we've got power coming back. This is 12 volts going out. So power comes in here, goes over to no man's land, and then that's where we kind of can put the two switches, and then we'll hook it up to the rest of power. So let me get, let's see, strip this out, and then we'll have our area that we can work. And we'll have to redo, the power connection and everything, but that's not a huge deal. Oh, the soldering iron is not even turned on. There we go. Got 300 watts of energy going into that, so it heats up pretty quickly. So we'll go in and we'll get the wires out, and then get the solder out, and then put the new stuff in. Easy peasy. Lemon squeezy. And the laser is 5 volts, so we'll do 5 volt wiring to the other switch. One switch gets 12, the other one gets 5. I don't know if the laser works on 12 volts. It might. I don't want to blow it up, so I'm not going to try. We're just going to use 5 volts for the laser. The laser just helps you get in the middle of things because it's a bit fiddly, and it's possible that changing the distance between the two plates will help me make it less fiddly. But for the time being, I would like to have sort of a laser guide in the middle. Plus, when it hits the water, it looks really cool. All right, so there's that out. All of my old power routing. Now we need to get the solder out of there. So we use the Engineer SO2, I think it is. They've changed it up a little bit. There's I think a new version of it, the solder sucker. But this one's good because it's got the silicon rubber tip, which means that it can actually seal-ish to the thing that you're sucking through. And that allows more solder to flow out. Plus, this thing is made out of metal, so none of it melts, and you can refurbish it. You can take all the stuff out, you can wipe it all off, Try not to get too much lead on yourself. And then you can re-oil it, and it works just like new. Because soldering braid is not getting cheaper. The price of copper is, as usual, pretty high. So saving your desoldering braid for the real hardcore surface mount rework is a good idea. It's an economical idea. How's everybody's Friday shaping up? I meant to play Abiotic Factor last night, but I didn't get to it. I'm making a front lobby base, and I'm hopefully going to be working it up to 2 layers, but I'm just getting through some parts of the beginnings of getting through manufacturing area, which is a tough spot when you're at the level that I'm at. So I did a little bit of strength training so that I could wear heavier armors without a penalty. What is it with me? Like, okay, so there's a game and it allows me to play a very fit character if I grind. And so I grind. But in real life, I could be very fit if I ground. And I've done it before. I've done the grind. I've done the regular exercise in order to lose the weight once. And I could definitely do it again. Why don't I? Why don't I? Because it sucks just a little bit. It's just a little bit annoying, so I don't do it at all costs. That's how I was in school. I would go extremely far out of my way to not do the work. And going extremely far out of my way to not do the work was the same amount of work as doing the work. But it wasn't as fun. It just wasn't as fun. That's kind of what we're doing here. We're going way out of our way in order to do something cool. It's something in my genes. All right, so that's all cleaned up. So we've got our 12 volt in from here. We've got 12 volts going out to the motor controller, and that powers the 5 volts coming back all the way over to here. This is going to need another wire that comes over to this side for the second switch. So this can be removed, this can be moved or removed. Let me peel this up. Our grounds are already connected, so if I can not disturb that area, we'll be fine. I'm not too worried about this being sloppy, as long as it works. As long as it works, because then we can put it back on the shelf. What? I didn't do anything. We really don't need a ton of status lights on this. I was thinking like we could do a 12 volt LED. We could do a 5 volt LED. The Arduino has an LED on it. As long as that turns on, I think we're okay. And then perhaps at some point we may hook up an ultrasonic transducer just to check to see that all of our transducers are working. If the chips are down and we can't seem to get anything to work, apparently that's the strategy that we're supposed to do, is hook up a transducer so that we can see that everybody's working with each other. And we have one left over from the distance sensor. So we can use this one. We can hook it up to 2 wires, look at it on the scope, and just see if all of our ultrasonic transducers are doing their job. Do your job. Okay, so these switches, of course, are much larger than the perforated prototyping board. So we need to kind of drill out a couple little holes here, and we just need to determine which ones those are. This is all the fun of building electronics. You guys know the score. So I have moved heaven and earth to get switches to mount in these perforated prototyping boards. But it looks like I'm going to have to go in the middle of 2 holes, center, and then again in the middle of 2 holes. And the closest these get to one another, so we do that, and then they can both be centered. I can't see the yeah, so it's 1, 2, 3, 4. How many gaps between them? 2. Okay, two gaps in between. the legs. So now we need to find a drill bit that's barely larger than the pins of this thing. I think this gets into, since this is it's a solder lug. There are two ways to do switches on boards like this. One of the ways is to drill out these holes, and then whatever I can get to in terms of solder nearby is fine. Or I could mount this part of the switch to the board itself and just use wires, but I prefer to do it this way. And I could potentially surface mount these. I could just surface mount these, but then I'm worried about mechanically whether or not they will stay on the board. Because if you brush your hand up against this, you are relying on your solder to kind of hold the entire body of the switch against all the torque of you hitting it from the side. So I think I would prefer to drill through the board, and then it's going to be like monstrously stronger. So let's find a drill bit that fits this, which is kind of a big drill bit, but we'll see. Kind of big for the stuff that we're doing. That brings me over here to the derelict part of the shop where there are no lights. It's the open surfaces that get populated with stuff so easily. All right, you know, did I popped out? Yeah, I popped out a YouTube chat. Oh, that's the perfect size. This is the perfect size. It must be an inch drill bit. It's the perfect size, but it's absolutely huge. Are they very snappy switches? Yes. I would have preferred to have little slide switches though. Slide switches would be better for this specific application, but yeah, these are the, for like synthesizers and stuff. These are the very snappy sort of panel mount switches. I don't like this long neck. This is good for like panel mounting. So this is good on something like a synthesizer where you want sort of visceral, clippy feedback. Now these are pretty cheap. These tend to be more expensive because they're more mechanical stuff than like a cheapo, super simple switch. I would prefer to have a little slide switch because that's all that's needed here. I just don't have any. Let's buy some. I'm gonna buy some before tariffs screw us all in the pooper. These the things that I'm ordering lately are like the last orders that I'll be placing for a long time. I have enough stuff in this shop that I've accumulated over centuries of doing this kind of thing, where if I don't stop buying the low-level supplies, I will never get above this problem. I will keep accumulating things. And due to, you know, the wingnut in chief, that was the nicest thing that I could say, and even that hurt a little bit. We have tariffs on all this stuff now, so I got to be careful about what I'm ordering. I know places have stock of this stuff, but I think it's going to be more responsible to simply avoid all of that stuff and concentrate on using things that I've already got in the shop, because I have what I need. I should not be purchasing my way out of problems anymore. I've done that enough that I've got extras of literally everything in such a supply that it's not going to hurt if I get a little bit creative about how we solve problems. What about a momentary button, toggle on off via software? That's where we ran into the problem. That's exactly the problem. You've described it exactly. Not the stuff that I was talking about before, but why are we here with this project? It's because I tried to make my own software, and it kind of worked, but my own software would allow me to have the flexibility to do things digitally, like have the laser on a button. That's what I wanted to do. I wanted the laser to be on a button, but their program is so rigidly structured for speed, I don't think I can put something in there. I don't think I can put Arduino code in there to use our own button for our own purposes. Plus the laser is 300 milliamps. I would have liked to be able to dim the laser. That was one thing that I wanted to be able to do. Add a transistor, dim the laser. What we're doing right now is we are going to compare their software to my jittery software to see whether or not it still floats stuff. And if it does, I could get the switch out of there and replace it with a button that would allow me to fade the laser with another PWM, right? That's why you need hardware PWM. You think you got all the answers. Shush. We're doing this my way. We're going to try this out. And if it works and it's not completely intolerable, it gets shelved. because I have too many problems right now. But yes, you're probably right. And Chad is always right. Whatever. If I put a PWM on it, that would be great. And I use hardware PWM, and I told it, hey, hardware PWM number, whatever, I need 40 kilohertz. And it'll be like, what? And then it'll output that with 0 jitter. Although the software has it so that if you hit the other button, it'll change the phase delay between the two signals. The signals that go to the top and the signals that go to the bottom, you can change the phase delay. And so that'll end up moving those high and low pressure areas so that you can actually move the objects that are floating up and down using the buttons. That's sort of what they built in. I don't know if hardware PWM can give me that phase delay. If I have 2 hardware PWM engines and I give it a microsecond delay, then I think I can affect that distance. So, maybe we will do the hardware PWM route. It's just that right now, we would have to retool the hardware in order to do that. And I don't want to do that. So that's where we are. So I got to build exactly this. And then I have to have switch number 2 on the 5-volt line. And switch number 2 is going to turn on and off the laser, which will be very bright and use a full 300 milliamps. Capiche? Do you guys get that? You get all that? All right, so if I were the type of person that had a power drill within reach of, oh, there's one right here. Okay, so we'll just use the hand drill for this. I do have other weird drills that I can use, including a screwdriver that I use as a PCB drill, but we got the full thing sitting right here, so I might as well just use this guy. My dad got one of these of the more modern ones, and they're even more compact, which is really disturbing. These 3-phase motors in power tools, it's getting out of hand, but it's awesome. It's the good kind of out of hand. Shut up, Fatanon, you know you love me. All right, so let's see. We go here. You just got a new one? Is it one of the super duper compact ones? I should probably drill over something. It's tiny, but it's brushless. The brushless motors are crazy. They're crazy. Here, I guess I'll just do this like this. So 2 spaces and then this one. And then center there, and then I go here. I do wish I could... Oh, come on. Hold on one sec. I'll wait to talk. No, reverse doesn't work. I don't find that to work very well. I do wish I could do slots for these. I probably should have done that, actually, is just kind of core it out with a knife. All right, so these center ones are going to be tough to get in there. Yeah, it's going to be exceedingly difficult, actually. Oh, did I get it wrong? No, they're just a weird distance. Yeah, the holes are going to be a little too close to each other, aren't they? This is a bit too destructive. Maybe we should rethink this one a little bit. Or we could just send it. I don't think I have a magic string. Thank you for subbing. Wow, that looks so much better with a shadow on it. Holy crap, that looks better. Magic string, thank you for subbing. Tier 1 for 3 months in advance. Oh, that's cool. I wonder if that pays out month by month or if it pays out all in one. Well, Magic String decided that they would rely on my content being consistent for the next 3 months. So joke's on you. I really need to put a button on that. I need a separate button for this joke because I'm looking around for my funny scene that's technical issues, but it's buried. Oh, I've got it over here. Yeah, I got to remember where this is on the Stream Deck so that I can say, Magic String is relying on my content being consistent for the next 3 months. See you then. And then everybody goes, haha, funny joke. That was great. What snappy scene changes you have, Bother. I need to memorize the Stream Deck XL and all the locations that I put stuff in. So like that drill bit looked like it was a perfect size match, but it seems like it's way bigger than the feet of this thing. So I've already made a big fatal error putting huge holes into my circuit board. But since that was a full send, we need to do it the honor of remaining a full send. Let's try to find a slightly smaller drill bit. And so I can just put a hole right in between those two. Inevitably, it's going to walk in either direction. Let's just see if I can find a smaller drill bit in order to do that and do our best. See, the best place to do this kind of PCB drilling is on a flat surface with a pull-down like drill press. And it needs to be super duper high speed. And, you know, you need to put the little dot line in it, the little dot in the material so it doesn't walk all over the place. We will do some of that due diligence, not all of it. Let's see, we need the center punch. This is a pretty good one. This is one of the manual center punch that you use a hammer with. So I'll also need a hammer. And I have just the little tiny, cute little hammer to use. Little tiny tack hammer. And then we do all this work in order to get the drill bit to go in just the right spot, and it inevitably just walks away. That was a pretty bad hiccup. That was a pretty bad hiccup to have in the middle of talking. Let's do a block of wood for the backdrop. That's good wood. I don't want to use that. I need crappy wood. This is good. Some crappy wood. No, we'll just work like this. There you go. You live like this? Okay, so we work like this. Yeah, drill bits walking around. I think it's why most of my... Oh, this is actually... I need something sharper than that. I need something a little sharper than that in order to make sure that I'm in the right spot. I mean, I guess we can use the auto punch, but this thing never auto punches. And it's fiberglass, so it's actually a really weak material. I'd rather have like the tack hammer so that I have a little bit of control. So no matter how careful I am with this, it's going to end up making me look like an idiot. Okay, that worked. Yeah, see, now it doesn't... Although just the pressure of me pushing down on the auto punch is probably enough to put a little mark on it. And then all of the... If I were a machinist YouTuber channel, which, you know, we're kind of close to one. If I were a machinist YouTuber channel, the next thing that I would use is these things. You see Click Spring using these all the time. Using these little guys to kind of start the hole. So I'm going to try. Bother, don't worry, you always look like that. I really dislike the oafish sort of, oh, look at this guy, he's an oaf. Everybody tries to put that stereotype on you. I don't know if that did anything. I hope it did. Try to find the punch. I did everything that I should have. I did all of the steps perfectly. And in the end, it's just not going to work. That's how these things always go. Where's my little drill bit? There it is. Maybe I shouldn't talk so much about my little drill bit. Little drill bit in a big drill. Okay, so save time and remove steps. That's kind of what I'm... Oh, wow. The perfect drill bit. Try to get that centered. Try to get that to close. Hopefully it holds onto the bit. This is kind of small for this drill. Clamping action time. With vice grips. Oh my God. Kung Fu grip. That is really shaking the camera, isn't it? Wow. That one walked over to the left. Come on. This never fucking works, does it? That one walked over too. It never works. Never, never. Look at this. Plan B is to do what? Cover this over with another type of switch so that I never have to look at this monument to my own personal building abilities failures ever again. Turn the switches sideways and do them in the other direction. See, it probably would have been better if I had planned on the pins to land in the middle of the rows, and then I just used the X-Acto knife, not the scalpel, to kind of stretch the holes out until they met each other in the middle. And then I would have little tiny slots with solder pad all around them. And that would have worked a lot better than going straight to the drill. I don't know why I did that, and I ruined the whole board. So we're gonna keep moving with this, but I'll figure out what to do from here. What's up, Celia? Celia, how you doing? So we just screwed that up pretty monumentally. I have it documented. Now you know what it looks like. What not to do. What not to do in the face of every opportunity to do the right thing. We decided to do the worst. What can I do? I could solder them directly down to the board, although we don't have pads anymore. I could do them like from behind and then have larger standoffs so that the pins can completely be underneath there. That's not great. Printing fidget cats. Solder them from the sides so that they stick forward like this. That makes them even more susceptible to running into stuff. Or put a piece of wire around the top and solder them sideways to the board so that the wires are just sticking out. I'm tempted to do that. Can I fit them both side by side? No, but then you need a piece of wire over the top and it gets a little sloppy. Yeah, that's a bit much. Think. What am I going to do here? Just have them as wires that you have to twist together. Or put the switches somewhere else and have wires go up to this board for the power routing. This sits here, the 3 buttons are there, and then I'd have switch, or find some different hardware that's going to do the job. Let's see if I've got other hardware that's going to do the job. Man, I really messed that up. It just happens sometimes. Sometimes you just mess up. See, I don't have a kit of micro switches. I think I need to get something like that. It is a conspicuously absent, oh, thank fuck, people finally went inside. I can finally talk in a normal voice. I don't like it, it's a weird thing about streaming. I don't like it when people can, like, hear me. Just a weird thing about streaming. Can I find 2 of these switches? Wait a minute, these are switches. I don't know if they can handle the current load of the entire project, but these are little push button switches. Maybe I could use these. Yeah, these are very flimsy and I don't use them anywhere, so. You have an ANET A8 and your house hasn't burned down yet? ANET A8, what's that? Wait a second. You mean the, what is the ANET A8? Is that the Aviom thing? Oh God, it's covered in a lot of dust. Oh no, that's the A16 too over there. What bottle? What bottle are you talking about? This one? This bottle right here? It's fine. Good luck with the project. Thanks, Theo. Wait, which was the ANET A8? What are we talking about? Burning down my house. Burning down the house. I'm gonna have to Google this thing because I don't know what the hell you're talking about. Hold on a second. $3D printer? I don't have that. Who has that? Somebody else? Is that a chat comment? Oh, Celia's got one. Yeah, so this one was the one that came under fire for burning down a bunch of houses. It's a very minimalistic 3D printer. Yeah. Okay, $200 3D printer. With the cheap 3D printers, one thing that you really have to watch out for is that they are using flexible enough wires in the places where the wires flex. They don't really kind of check that over. All right, so we're gonna cover over my horrible drill work by putting in 2 of these little push button switches. And that will fully mask all of the terrible stuff that I just did and allow me to have 2 little buttons here that turn on and off 2 little things. Now, hopefully these can handle the load of the rest of the project. Oops. Keep dropping stuff. Yeah, so these aren't 0.1 inch spaced. It would have been nice if they were, because then they would be larger and they would be able to cover over my horrible drilling, but we'll just do it like that and that should be pretty good. I could always get like 3mm LEDs and put them through there. I don't know which direction is going to be more economical here. A little bit smaller. Fight fire with fire. Whoever made up that phrase does not know how fire works. All right, come on. There we go. See, it's like it never happened. Like it never happened. All is forgiven. All is fixed. So when I get that Erica Synths MIDI thing, we'll have a stream or 2 where I build it. Excuse me, sorry, I was burping. I ate like the majority of a hoagie today, which is probably too much food. I still need to take the GLP inhibitor medication for today, for this week, upcoming week. But it's made me extremely burpy. Probably should have been a little bit more careful. Also, caffeinated soda for once. I haven't had a lot of that lately. It's been kind of a cheat days. So these are SBDT. No, DPDT. No, DPST. Dual pole single throw. I can't imagine what it's like for you guys who aren't native English speakers in electronics, because it is hard enough for me to keep track of all the terminology and sayings and stuff. And I can at least infer by knowing the language what something might be called based on the nomenclature standards that we have, but they're all native English standards. Dual pole, single throw, surface mount, through hole, what is it? No pad, yeah, just all these different names for things that just don't correspond to other languages. Crazy. All right, so anchor pad, I think I should do it on 2 sides for this, and then I'll push down on the switch and go over the pads again so that this thing can fully seat itself. Make sure the iron's on. I have a feeling that all of those people just left the house without walking the dog. I did take her on a walk recently though, so she should be good for like a bunch of hours. But yeah, I may have to break early to walk the dog. I don't want to do that because it's Friday. It's Friday, and I probably get more viewers from people who are, you know, getting out of work. Although paradoxically, this stream has a lot of people who watch at work. So Friday's not a great day for me to stream. Maybe I should do Tuesday, Wednesday, Thursday. I don't know. We got a good thing going. We're going to keep doing what we do. Come on. Seat further. These are like two different designs. It's very strange. They're the same thing, but they're two different weird designs. And these buttons I actually hate because these tend to break. These break fairly easily. Is that top piece soldered? No, it's not. So why isn't it seating? Why is this being... Why are you being a stupid head? Well, it's mainly because the pins are being stretched. All right, there's nice flush mounted batons. We can just solder the rest of them now. Man, that kind of ruined my nail a little bit. A little part right there is not doing too good. Traces on the PCB and the mixture of no thermal protection with the firmware. Firmware can be updated and changed, so that was an easy fix. The ribbon, they found one error. Oh, see, what I ran into was the printer used the high temperature wire, the aluminum wire, in the flexible part, and they had it just like loosely draped over to the controller. And so with, you know, years and years of use, that eventually caused a break, which caused a spark, which could have been really bad. But I don't live in a oxygen-rich environment. I don't have fuel and oxygen mingling in the air at all times. So it didn't cause any problems, but I had a few prints have kind of like a thermal error and then stop, because as I was slinging the bed around, it would disconnect and then the thermometer would dip it would dip low. And then the printer was like, hold on, something's not good here. Something ain't right. On reflection, these are not two different switches. I simply put them in the opposite orientation, and I now realize that those markings are actually to keep... Okay, do we need to remove one? Or maybe I can just work around it, because like it'll be the inner ones or the outer ones will be the ones that I'm actually using to wire the switch. But it's going to be, maybe it'll be a top to bottom thing. I don't know. Let's figure that out. Let's get this thing on the multimeter. Just a simple, like a quarter of a second of reflection as to why the two switches had two different weird snaps on the one side. And I could have figured out, I could have known that I was putting them in the opposite way. But I'm not an oaf. Don't hit me with those oaf stereotypes. All right, so I use ohms, I don't use the beeper. That's because I keep the screen visible. And when you are probing around with the multimeter, knowing the amount of ohms is going to give you more information than just a simple beep. That beep has sort of a loose criteria for what it counts as connected. So if you go through your traces and you've got like a 100 or a 300 ohm resistor there, sometimes the beeper will go off. It'll say, it's whatever, that's enough voltages, it's fine, we can just beep. And you go, okay, there's continuity between those two, but in fact, there's actually a resistor in there. Or if you're probing near something you need and you don't quite get it right, you can see, oh, there's a 3 kilo ohm resistor between these two probes. I know that I'm on either side of this trace. Let me go over here and you know exactly where you are. with the beeper, it's really looking for either the voltage drop of a diode or an overload scenario where it will then create the beep, like a low ohms scenario. It's just not useful. It's just not that useful. I don't ever use the beep feature. I think I've used it once, and that was when you can't see the screen. If you are contorting around your car and you don't have the ability to look at the screen, fine, use the beeper. But in every other scenario, you're going to get more information from ohms. And what we're looking for is low ohms. So anything in the realm of 1 to 0.5, 0.4. It depends on your equipment. Obviously, the test is always just touch the probes. Touch the probes together. Nobody will think any lesser of you if you touch the probes together, just as long as you keep the bodies separate. You just touch the probe, just the tips to one another. You just touch those tips and just whatever happens, happens, right? Nobody will judge you. So anyway, let's take a look at which one's the normally closed and the normally open. So in switches, you typically have a row of 3 pins, and that's a SPST, DPST, SPST. Sometimes you have a center off in it, but usually you will have a common, a normally closed, and a normally open. Typically, the common will be in the middle because the mechanism of the switch is easy enough that you just short these two or you short these two with a contact. Some things can violate that. Sometimes you get a switch where the common is on one side and then you get your closed and open. So the drill is you just look for what you think is the common thing, look at the, probe the pin, see what's going on, push the button, see what's going on. It's nice when you sit in the lab with lots of other coworkers looking for faults. My own personal hell. No, you get an entire lab full of people and they have one beeper to share between all of them. So I get very low ohms. I flip the switch. I get open circuit. I check up above. On the 3rd pin for the common, I get very low ohms. So it is center common. Okay, and so when the switch is pressed, it connects to the top. Now the one next to it is going to be in the opposite way, isn't it? So when the switch is pressed, it's going to connect to the bottom. No? Oh. Wait. They're both like that. Oh, no, never mind. Okay. So it's top is connected, bottom is connected. Well, that was the opposite of what would have been useful. That's actually kind of useless, although we're going to be wiring things up with wires, so it doesn't really matter. We can just get everything to connect. We can make that work. Yeah, I use the high voltage add-ons to the multimeter probe because it's got that very, very sharp tip that's small. And so I can poke through oxidization, and I can even poke into the traces, the ground plane on something like this. I can poke through the solder mask in order to get continuity on traces. So they're very useful to have the super duper like needle nose tips that can draw blood every time you mess up with them. I'm due for a new pair of those. I buy a new pair every now and then. Okay, so we need to wire this thing up. 12 volts I have going in here. Oh, that did not feed cleanly, did it? Why are you not? Hold on. Straighten that out a little bit. It's like little bits of solder residue on the hole, I guess. Or no, it's just the jacket of this thing is weird. What the deuce? Go in there. There we go. Something ain't right. That's just been in my head all day. Curse you, Hackers 1990 soundtrack. So this one will go up here to, I guess it can go to common. We'll take this one up to common. This goes to here, and then this needs to get 5 volts, and it switches to the upper one. This one switches to the lower one. All right, that works pretty well. And then in the future, if I need to add a capacitor, I can put it in here. Easy peasy, lemony squeezy. Let's get some wire. Just get a random scrap piece of this wire wrap wire and cut it. Oops, sorry, I'm covering over on my camera stuff. Ow, poke myself with the tweezers. So I got these new tweezers. These should hopefully be useful in stripping this wire. Nice and easy. Did I flatten it too? I think I might have flattened it a little bit. I just got to get used to them. But it seems to work pretty well. No, give me this. I just got to learn them a little bit, but it looks like it's pretty effective already. So we're going on this one. Oh, I did flatten it, didn't I? Did I? Yeah, there's kind of like a, it looks like there's like a flat spot on the wire. That's weird, huh? Tenmas? What is that? All right, get that soldered, and then put a little bend in it. So I'll take it out to here. A little bit further in. I kind of want it centered on the row. This is a technique that I've been working for a long time. I did not know that you could just buy wire stripping tweezers, and there are expensive ones and there are cheap ones. I bought the cheap ones, and I think I'll have enough control with them, hopefully. I ain't gonna go blind. The light that is reflected. Every single like radio station that went out to a bar in the 90s in Pennsylvania would play that song. I ain't gonna go blind. It was just on a repeat. So it's like, if it's in my head, it's not leaving. Mexican radio? What do they got on there? No, this is the song in my head. This isn't me being on a radio. This is just my own brain playing stuff constantly in the background. It's not like, oh no, I got a song stuck in my head. It's what song is stuck in my head now. It just plays and plays and plays. I can't stop it. Things are a little bit jittery and shaky right now because I don't have this thing attached to anything. So it's kind of freewheeling around as I try to solder to it. This is one of the main reasons why I use the mechanical vise. It holds something like this steady so that my iron isn't moving it around as much. We are forced to work like this because I'm doing some rapid modifications to our circuit in order to run this thing properly with the software that is not mine. Auditory memory rules. Oh, it's a song. Oh, why didn't I see? I bet you if I heard a little bit of it, it would be locked into my brain, but I'm not willing to risk it. I guess I'll take it over a couple holes. We got a little bit of space to operate over here. We can kind of be free. Unless I wanted to put the 5-volt switch over here. Or the 5-volt connections, rather. You heard it this morning. It's been there all day. Oh, no. This is the worst. The worst. Bing, bing, bing. Where'd the cutoff go? Where'd the piece go that I cut? Make sure it doesn't get in anything. You get the hacker's earworm in my head now. Listen, I got the whole movie memorized. The whole movie. A friend and I used to quote it, a college buddy and I used to quote it at each other all the time. It's a cheesy, stupid movie and I love it. And then they published the soundtrack and it was different songs. It wasn't the same songs. They were good songs, but they weren't the songs from the movie. It was just like a promotional album. And everybody made fun of me for listening to electronic music in the 90s and early 2000s. And we said, listen, this is going to be the music that you guys are all going to listen to in the clubs. And while that may not have been true, it is now. And then it turns out we were in a golden age of good music. Nobody realized it. Now, there are still people here. I thought they all left. Hopefully somebody's going to take the dog for a walk. I haven't seen Hackers in a good while. Oh, hey, it still holds up because everything in it is silly. You tell your kids, this is exactly what the 90s were like. Cyber raves that go all night, where people have computer books. Let's bring our computer books to the cyber rave. Yeah. Philly was the spot for techno. Oh, the parties. We used to go to a place called Motion Nightclub. I don't know if it's still there. I think they had a Function 1 sound system. That was a hell of a part of the riverfront where we definitely should not have been. And then I went to one rave that was called God's Basement, and it was in an old church. And we could just take the train from the suburbs. So, of course, I'm at Matt's for a sleepover. 611 was always a stop. DJ, what was his name again? DJ something or other sucks is something that we would always say when we went there. But I bought a lot of clothes and a lot of music from 611. A friend of mine once found a record there that was all bondage, songs about bondage. And it was hilarious because you could go to any given track and it would be just something utterly ridiculous like, I got the sandpaper ready, spread them cheeks. And you're like, what? Wait, whoa. What? There's a DJ. No, I don't remember what the DJ's name was. Yeah, that was my scene back in the day, way back in the day. Mr. Mom? That movie I do not think of when I think of Hackers the movie. Yeah, for anybody's on South Street, which is like a gentrified shop street in the city, there was all kinds of cool places. There's Zipper Heads and Jim's Steaks, so you can get a Jim's cheesesteak there. All kinds of different shops. The one called Agent Orange that had all the weird rave clothes. And then there was 611 Records, and then later on 611 Clothing. 611, that's one of the area codes of Philly, right? I'm a 215, but anyway, 611, oh no, Route 611, wasn't it? Because it's done like a route sign. Anyway, that's the record shop that had all of the electronic music in it. And it is where all of my friends would spend all of their time because they all wanted to be DJs except for me. I just wanted to go into the city to look at the cool stores and maybe buy something weird. But they wanted to go in there and listen to 5,000 records, leave with 12, and then DJ with them infinitely to no avail. they learned how to mix vinyl, but that was the days of vinyl going away. So, and then it became CDJs, and then it became those like indexing inserts that you would put on the record player that would then work with your MP3s, and then from there it's just mix it on your computer. Like you say that vinyl has always been coming back, even when it was going away. Okay, so we got the power wiring done, right? We have it so that this thing will turn on and off. Now we need to do the 5-volt stuff. Went to a store and it was all vinyl. I hope it stays kind of vinyl, but in terms of like some of my friends who actually have gigs, friends later in life who are actual DJs, who actually do shows, the people who I kind of listen to as stream intros, they're all using their computers now. It's just not worth, it's not worth having something you can bump and have the track go, you know? In terms of personally collecting music, vinyl is of course still mega popular and super awesome. So I'm just saying, in terms of like DJing, the sound quality for digital and its ability to not have a drunk person stumble over it is an advantage in this new and wonderful technological landscape that we live in. Am I a bitter old man? Well, I'm not that bitter. When did that happen? I used to come on stream and go, geez, you guys, all my friends say they're old. And I'm like, you're not old, you're 30. And then now we're old. We're not, you really shouldn't refer to yourself as old if you're in your early 40s even. That's just the internet telling you that you are, because we're so long out of school. But really, lifespans are ever increasing, and old does not just mean gray hair. You guys have seen Julian come in here and do his shenanigans alongside me. It looks like I'm somehow the calm one between the two of us because he's bouncing off the walls with energy. It's amazing. And I would never, ever refer to him as old, but he has more gray hair than old people. So it's just one of those things, like, you know, it's I don't know. Middle-aged, I don't know. I'm reluctant to say. As a diabetic, maybe I'm in my later years, but still, actually no, diabetics live longer, to be honest. You know, am I going to make it to 80? Yeah, I think I probably am going to make it to 80. So I'm not willing to call myself middle-aged. Worn down, yes, I'm a millennial. Of course, I'm worn down. But old, I don't like to say that. I don't like to say that. I think it's selling yourself short. I was saying that I'm going to make it to 80 and beyond, like fairly easily rather. I don't care if you're diabetic, you're funny. Wait, what is, huh? You've reduced me to my humor. That's all I am to you? All right, so we got power to a switch that could maybe handle it. We need to get 5 volts, and 5 volts comes in and it immediately jumps all the way over here. So I guess what I'm gonna do is, well, this is gonna be a little painful if I do it that way. I was gonna make a little junction right here where I can peel off another wire that would go all the way over to this one. Ow, these things are pokey. These things hurt. I'm unwilling to call myself middle-aged. I'm unwilling to, I don't think that's, I think that's, I'm not gonna say incorrect, but it's, I don't think that's the, no, I turned it into something mean because it'd be funny. Don't get me wrong here. You guys have to push pretty hard to get me to be annoyed. Yeah, don't get it twisted. This is a comedic, lighthearted electronics show. I am not gonna take anything too personally from you guys. Worry not about insulting the streamer. I pinched too hard on that. I pinched a little too hard. Let's try to get this one. These are new. These are wire stripping tweezers. They're not specifically wire stripping tweezers, but they are kind of like right angle cutoff tweezers. And so theoretically, I can use these to neaten up this process of using wire wrapping wire. Yeah, one of my early projects was using electroluminescence on a pair of raver pants. And so I had a mercury switch because we didn't really have accelerometers so available back then. They existed, it's just this stuff was a lot more expensive way back then. So what I did is on the raver pants, I put a pair of stripes going down them that were the EL, the electroluminescence stuff, in their plastic shroud, but the shroud was sewn down. So I had to cut sort of part of the shroud off in order to make that possible. And then I had them running to a little box that was screwed onto the pants permanently, which, boy, I gotta tell you, that's hard to explain to a bouncer while you have a frickin' IED on your hip, permanently attached to your hip. I'm like, okay, first of all, actually, no, I didn't have an insulin pump back then, but boy, that would have been even worse. Oh, this is an insulin pump, and then this is a little electronics box. It was a metal box on the pants. It's ridiculous. But I still got into clubs with it. Which is crazy. And so when I was bouncing up and down dancing, they would be lighting up as kind of like the Skechers. And then I hear people walking down here. Why are they coming downstairs? I ain't gonna go blind. No. Okay. There's our junction for 5 volts. And then I'm going to take another red wire on the other side of the board and go up to this one. This one connects here and here because of the whimsical way that I did everything else. How does it work on magnet wire? I haven't tried it yet. Let's see. So thin magnet wire is a particularly annoying thing to strip. If we can just rub the side hard enough, we could potentially open this up to solder. These are little grippy, grabby hands. Nope. Possibly serviceable, but it's not a magic bullet. I think what I'd like to do for magnet wire is to either take 2 nail files and make them into a pair of tweezers, or if I took two micro files and like cut them so that I could screw in these, although it is hardened, so that might not work as well, or just glue a piece of sandpaper to these, and then I can just grab the end of the magnet wire and just pull, and it'll sand off the material. I think that's the best for magnet wire. The lighter method never worked for me. Where's the multi? Yep. Red wire. Now I need red wire. We have to color code this thing, because if we don't, there will be chaos in the streets. What is? Oh, I was holding a piece of foam and I was hearing crackling noises, and I'm like, what is exploding? It was just the foam doing its noisy thing. I don't like the lighter method. I think it leaves too much residue behind, at least when I do it. If it works for you, it works for you, but I just don't like it. I need something else. And I think my best bet is going to be some kind of a nail file style tweezers. These work pretty well if I'm careful with them. The thing is, the front meets first. See how it meets up here? And you kind of use that to your advantage. So it grips less in the back end and it cuts in the front end. Yeah, what I would do is drag it on the file, and then that worked really well like once or twice. And then every other time that I've tried it, it's just been chaos. So there's a technique in there somewhere. I have not discovered it yet. Nobody's judging. You can do whatever you need to strip. It's fine. Let's see. Grab this. Ooh, don't fall. Don't fall. Don't fall. Don't fall. That song is not going to leave my head, and it was the song that I liked the least of any of those radio DJ party things that they would do on the weekend. Look at us, we're at a party. It's like, shut up, DJs. play some regular music. What am I working on? So this thing is going to levitate things like drops of water. We have two pieces of code. We have the code that the PhDs made, and then we have the code that I made. And my code it doesn't work quite as solidly as the code the PhDs made. And we want to test both of them. In order to do that, I need to retool some of the hardware because we're not as flexible as a normal microcontroller program is. Instead, we've got this weirdly coded machine languagey kind of Arduino program that has to have certain pins do certain things. We can't retool that. So I need to change the hardware around. I thought I'd be able to come up with my own software and it would work perfectly the first time, every time. But that didn't happen. So right now we are hooking it up so that it has power to go to the laser so that I can properly align the things that'll float in the air. I want to make sure we put our best foot forward for this thing at first, at least, and then we can test out my own program. So this is for this ultrasonic levitating thingy that we found broken in my storage bins. Fixed it up, what little there was to fix up. Now we got to get software running on the Arduino so that we can get the ultrasonic transducers to do stuff. So this is sort of resurrecting an old project. This is an aside from what my normal projects are. My normal project, the most normal of my projects, being Burn the Subs, which is a giant board on my wall, what burns the names of subscribers onto itself. It is currently not working, and it has been not working for only about a year or two or three, because I have been improving it slowly and methodically, because I have the ability to take a little bit of time on it, so we're doing the right thing. So you're talking my language. This is the Burn the Subs camera that's on Mess. The face camera's over here, but Burn the Subs is this board that sits behind me. And so we've got now a water-cooled laser that should do, was that supposed to be a fart? Or did you just 5 or so years? Has it really been that long? I've got the path forward mapped. I know what I need to do in order to get there. It's when you work on stream, you explain yourself a lot, and that takes up a lot of time. Takes up a lot of time. So we're gonna get it working again. I mean, I've been working on it, so. Well, yeah, during the pandemic, I didn't really work on it because I had 2 other versions of the board that did gangbusters for a while. And so I kind of rode that out and let stream kind of calm down and let myself kind of forget about it for a little bit. But it's come time that it should come back. And it's not for any sort of a financial push. I don't really need Burn the Subs to be functioning. And it's not really for a popularity push because given the political climate, I don't know what's going to happen in terms of the assistance that I have to get medical supplies. I don't know what's going to happen there. Hopefully Pennsylvania can stay a little bit sort of on target with that for a bit and I can continue. But we'll see. And right now I'm okay, you know? I like your yapping. I'm a dog drinking water. Slurp, slurp, slurp. I like your yapping, but what does the blue thing do? You said transducers? Yeah, so what these are these are ultrasonic emitters, and they are all in alignment with one another. And when you power them all on at once, what it does is it creates a sound front, an expanding wave that moves in a direction. And those individual waves coming out of all of these different transducers create an interference pattern. And it's a pretty complicated interference pattern, but when everything kind of balances out, you get high and low pressure areas in the air where there's a lot of sonic activity and where there's very little sonic activity. And so what you can do is you can balance very lightweight objects in those sort of divots of activity, and you can have them float in the air on a sound wave you cannot hear. So it's a neat little, technically it's a doohickey, but the doohickey thing that it does looks really good on camera. Tails has Sonic and Tails. Very hilarious. I'm so glad that you're writing the jokes today. Should it be on the inner one or the outer one? If I do it on the outer one, then I need to run ground all the way over here. But I can have the laser wires, I guess, go to this section. We'll try that, because this one connects on the lower part. Oh, this one connects on the upper part. What is that? Oh, jeez, that's going to be really annoying. I guess we'll go in from this side then, because I'll need to have a second wire coming up this thing. Really, the bone-conducting headphones use that kind of stuff? What the project that I really wanted to do, and this was in response to people at festivals with megaphones. People at festivals with megaphones will run around with their little egos, you know, insulting everybody around them, because it's funny, and they'll be loud and in your face and on a megaphone. And what you can do with these transducers is you can put them all in an array. And when you put them in an array and you drive that array with audio, like, well, you're still driving it in the kilohertz range, right? You're still driving it outside of the human hearing range. But when you drive it with regular audio, the kilohertz signals going into these speakers, the interference patterns create audible sound. And the interference pattern persists in a linear pattern going forward of the speaker. So when you have an array like that, you can also have one of those spy microphones. And if you put a delay between the output and the input from the spy microphone, you can tune in to the psychological delay phenomenon, where if somebody hears their voice with a slight delay, they cannot think of what they want to say next. So I wanted to do that project. That's why I have all these transducers. That was a hoagie hiccup. Oh my God. Okay. So if I have all of these transducers in an array and somebody is being obnoxious on a microphone or loudspeaker, I can then send their voice back to them. And while they are on this very public loudspeaker, they'll go, wait, I can hear my is that my voice? So it's more like a brain jammer. It's like a personal brain jammer using a laser speaker. So I want to do this project, and I thought it was really awesome. And I found this old HTML style website that had the same ideas I did. Because remember, there are no unique ideas out there. No unique ideas. You just better to embrace that. If you Google something, you are going to find that something, right? You're going to find somebody who did that project already. That's great. You can, you know, on the shoulders of giants, you can propel yourself to great heights. So I found a website that looked really old, where somebody wanted to do exactly the same thing. And so they had a whole paragraph about doing it. And I was like, cool, that's proof of concept. Proof of concept. You just said idea, and my idea light lit up. Cool, great. Somebody already did it, proof of concept, there it is. And so I'm reading this website in preparation of doing the project. And I'm like, cool, I'm gonna do this project. And what really, first paragraph, all technical, all details on the thing. Wow, great, cool, totally possible. Some guy's like, yeah, I wanna do this. Second paragraph, nothing but ranting about Obama, racistly. And I was like, it's the internet, fucking internet. So anyway, at some point I would like to do that project, but until I do, this one I am going to do first. I'm going to do the levitation one first. They were waxing about going to like an Obama rally and using this thing to get him to stop talking. And it's like, bro, like you're talking about something that's going to look like an IED. You're not getting in. Like, no, that didn't work. So the problem with the tweezer thing is that it does put a lot of pressure on the wires, and I don't know how hard to grip it, which is where the high temperature ones would probably come in handy a little better if I actually had a temperature wire stripper. I'm learning. We're getting closer to using these things properly. We're almost there. All we have to do is finish this and then reroute the button wire. You have an idea that nobody else has done. That's neat. Yeah, you should totally, I mean, gaining the expertise is hard, but the hard part about any given idea is actually executing the damn thing. That's where we are. That's what you're looking at right now is bother getting stuff done. Why is solder not soldering? What, this pin has really been just pissing me off. Okay, hold on, let's get this. Here, have some solder. See how much more agreeable that is? Jeez. Well, I mean, there was a viewer in here who wanted to make a bathroom cleaning robot, and I'm like, that's cool. And they were like, what microcontroller do I need to learn? And I'm like, so I get a lot of that. I get a lot of, I had an idea, and it's like, well, that's on you. You can figure out how to make your own idea. And they were always hitting up my Discord to try to get details on sort of what they needed to know to make their idea work, but they wouldn't tell anybody any detail because they wanted to keep it secret. Money is the main reason projects don't get done. Yeah. I did, you know, with a piece of CAD software, even the free stuff, you can do a lot of theorying for projects. You do a lot of theory crafting for projects on CAD. Which I've done recently. I found a 3D model, but it was from a game, so it's not to be fully trusted, but I found a 3D model of a 944, and I was like, what would it be like to make this thing electric? And it turns out somebody had already done it. There's a video on it, some European 944 that somebody turned electric, but I was like, man, this would be really cool. So I did the due diligence. It's all part of engineering, part of doing projects is the theory crafting phase. Ideas are fun and they always work in your head, but then you need to vet them out and sort of look at the nuts and bolts of the idea. And the nuts and bolts of the idea is that it would probably be somewhere in the $20,000 range for me to do that. And I don't have space to store a car, but I certainly don't have $20,000. So that idea just fizzled, boom, gone. However, if I did get popular in tech YouTube, I could probably make that amount of money in the time that it would take to publish all the videos of doing that. So it would be cool, but I'd need the infrastructure of a popular YouTube channel in order to propel me into that. And I can't even get Twitch right. So whatever. But yeah, you gotta have the knowledge to kind of run the idea out. CAD, I've found, helps massively in that front. It allows me to look at my stupid idea and go, okay, that's stupid. Or, oh, that actually has a little merit to it. I'm going to run it to these two pins, and then I guess maybe I will just run them out the side for the laser power. Or I could run them from here. That's a little, but over here is where we've got those two wires coming. It should come out of here, though. This is where the laser should be. This one is ground. Maybe I can just poke that through. That's going to be really annoying when the ground wire breaks, though. Now we'll have to figure out how to do that later. Okay, so switch for the laser that's not implemented yet. Switch for the rest of everything turning on and off. Both of these are off. The laser, I'm going to have to drill a hole for eventually. I guess we'll do that now. We'll do that now. So actually, what I can do is do the laser wires through this hole that I've drilled, this convenient little hole that I've put right in the middle of my circuit board. I can use as a strain relief hole for the laser wires. Wasn't that clever of me to do that? As totally planned. Totally planned. Totally planned. I don't know if I'm going to have enough wire on the ends of these. Well, we'll just wing it. Okay, carefully. Ugh. All right, this is tough. I'm trying to put the green laser wires through some holes so that they get a modicum of strain relief. Actually, you should go with that one. Maybe a little tighter, and then that would give it better strain. Although that's one wire, so I guess I can do that. Okay, we'll just go through here. Ain't gonna go blind. Stupid song. Okay, so ground to ground, power to power. I guess I'll just go over here. Nope, you got to spell it correctly. It's an acronym. Can't spell it wrong. We had AutoMod stepping in on a word that I don't allow people to say here. Hey, don't allow that. No, I will not allow it. I specifically flagged that word so that people wouldn't use it. You did not call it by the proper acronym. Oh man, I should probably crimp wires, crimp connectors onto the ends of these things. I literally just said I don't allow that term, and then you allowed it and said I'll allow it, as if you own the stream. My channel, my content. I don't know what the AWG is, but these things are, this stuff is turning into soup. The best way to get around that is to do like a DuPont crimp on the end of it and then just solder the DuPont crimp down, or a JST crimp, which is a little bit more compact. If you really want to know, it's laser, L-A-S-E-R, not Z. Z is light, simulated instead of stimulated. I prefer people use the proper term around here. So AutoMod doesn't tell you specifically what word was not allowed. I may have to make, AutoMod can tell you that, can't it? I think it can. I need to make it say that you're not, you're not spelling it correctly in some way, shape, or form. Oh, this is a terrible way to do wires. What you really should do, if you have to use this sort of like PVC coated wire, the stuff that like melts really easily, it should go through a strain relief hole, but then it should immediately solder onto the board like right next to the strain relief hole, and the strain relief hole should only be a little bit wider than the jacket. No, it's not. It's just not. Nope, we use the proper terminology here. Well, he is from Pittsburgh, so yeah, the yins are in him wants to spell things incorrectly. Saw one in the wild and he called it. Why did I wire it like this? This is all over the place. Whatever, I'm working quickly and I'm getting it done. I'm going to leave that alone, even though it looks like hell. I thought I'd have the 2 wires be on the end there, but I decided to use this stupid hole that I made earlier to get that wired in. I don't know. I'm just operating here. All right. So the one that's in the incorrect spot is this one. Instead needs to actually push the button over here. I am just going to go up and over and down. I'm just going to wire it directly. I don't care if this pin gets pressed in the operation of the other bit of code. It doesn't matter. It's not looking at that pin. So what I can do is just use an exposed wire and just staple it all together. There is a wire in the hole. Yes, yes indeed. Right there. Uh-oh. I'll have to go into either the auto mod settings, or I think maybe Nightbot I can get to say, to kind of do the slap on the wrist for the misuse of that word. Because it's like, oh, but we were only joking, but it also just reinforces people thinking that that's the real word. The acronym for a light emitting of stimulated radiation, or is that excitation? I forget which one it is. Light amplification of stimulated electromagnetic radiation. It's not electromagnetic. Wait a minute, that's the wrong one. But everybody wants to say LAZOR because it kind of sounds like the same thing. And if you're around as many Swedes as I am, Swedes and Danes and other Finnish people who spell entirely phonetically, Mr. Zoran, it wears on you. It wears on you. You start losing your patience, and then they go, but I'm just trying to communicate. Well, not good enough. And people don't really interact with laser as an acronym, as a word in a sentence that much. Also, it doesn't actually bother me at all. I just do that because it's funny. It's a bit. Streamers get mad about stuff that normal people don't really get mad about because it's funny to have an overreaction. I'm seeing the same blurry stuff you guys are. I just got to tilt this thing a little bit so we can see. Okay, so that's our rewiring of the button. When you push the button, it's going to bring 2 pins high, which is not a big deal, or low rather. It's going to connect ground to 2 pins, but it doesn't matter that it's going to a pin that's not really used. Oh, that really does remind me of the substitute teacher. Why substitute? Why don't I even, in your fantasy, why don't I even get the classroom? What the hell? What the hell is that? All right, so that's all done. Put this thing aside, and then let's go over here, and let's put our hardware together. It's going to work perfectly the first time, and it's totally not going to like get hot and start a fire. We also need to do some crimp lines too, but we'll start with this. I got a lot of stuff to still put together. The yapping? Okay, let me keep work. I gotta keep working. These are pan-headed laptop screws. They look really good in a setup like this where they kind of sit flat against stuff. And if you design properly with them, I've learned all kinds of ways to design for these with 3D printed enclosure stuff. They look really nice. You can get stuff to be nice and flat and still have all the screws in there for accessibility. Don't get too parasocial. I am not a real person. No, I mean, it's not the way people understand parasocial relationships. The fact that we are, even if we were good friends online, like really good friends online, that is still a parasocial relationship. But people have meant that, they've attributed that to streamers paying a modicum of attention to them, and they think that it's like this horrible thing and that's parasocial relationships. No, it's any kind of a relationship that isn't like present, like isn't like a having a cup of coffee across the table. That's a social relationship. Parasocial relationship means anything under the blanket of I have never met this person in person. Yeah, I don't want to hang out with you. I don't have that kind of like a standoffish relationship with the people in my chat. I know you guys, some of you, the ones who have managed to give me enough information to know about them. I know about you. I don't ignore the chat, and I don't have this sort of standoffish deal. I don't understand how some streamers do that. I don't know how they can treat their stream that way and still get thousands of viewers. I don't know. It just seems so privileged to me to be able to treat people like that on the internet. It's too much. I can't do that. Okay, so we've got the laser hooked up to 5 volts. The 5 volts is coming from the motor controller. The 5 volts is also going to the microcontroller once this thing is provided with 12 volts, and the 12 volts comes from the second switch. So this one here, on and off, turns on the whole ensemble. This one turns on and off the laser. I think we've gotten that pretty well. These are switches that I hate, so we're using them in here. We've got the button that wasn't... Wait, one of them wasn't doing anything. One of them, was it not wired? I don't know. We've got the one that didn't do anything is now wired to the third input, and then the other 2 inputs are the same as the original. This is why I mean to mute when I burp. I should have this mute button a little closer by. I'm having a caffeinated beverage for the first time in a while, so I'm burping. Anyway, so we've got the 3 buttons hooked up to the proper 3 buttons as per the schematic. So now we can run their code and see whether or not this thing will allow us to hover something. I guess we're going to do that instead of aligning the laser. The laser we can align later. What I'll do is I'll pop a hole in the top of this thing and then use hot glue to put it back into place. What I need to do now is I need to put ferrules on the ends of these wires because they do not connect properly. They don't seem to connect very well. Also bet you got a killer bench and fun tools. It's everything you guys see in front of you. I try to show all the nooks and crannies when I go spelunking for parts. Now, the question is, the holes that I put in this 3D print here, are they going to be wide enough that a ferrule can pass through? Oh, for fat, sorry. You got to use the little @ things so I know who's talking to what. Because I'm just glancing up a chat when I do this. I'm all over the place. The question is, do these small ferrules, the ones that I have left, fit? Oh, well, sometimes those don't crimp at all. You know what? I should probably crimp something over the wire, like a DuPont connector. I think that's a better idea. And then I'll just smash the DuPont connector into the screw terminal. That's a much better idea. I've been doing this gig for a long time, and it always accumulates a lot of stuff in a lot of different places. So yeah, you know, I have somewhat of a deep reservoir of cool stuff. A deep reservoir of cool stuff that I'm sorting through to find DuPont connectors. Wait, are those over here? No. That's another JST connector set. Another JST set. How many JST sets do I have? I don't know. One of these had DuPonts in it, right? One of the surface mount ones. Oh, but it's one of the surface mount ones that's way on the bottom. I don't want to fish for that. There's another set of buttons. Huh. Too many sets of buttons, I say. Yeah. I must have had it out. It must be out on the bench somewhere, because I haven't put away my toys. There's a bunch of crimp stuff over here. Well, it's because the good ones keep running out, and then it's cheaper just to buy the whole kit again. It's kind of a sad situation, to be honest. You can't get like a booster pack. I haven't opened this one yet because the good size of crimp goes so quickly. All these over here where I'll never see them again. No JSTs over here. What happened to my JST kit? Fart noise. Over here. Sorry, I'm looking somewhere else that you guys can't see. Nothing. No, it exists. It exists. I'll find it. 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 You'd hire a trainee to sort out all your stuff and log it into Excel file. No, but then you have to maintain the Excel file. Organized to the gills. People who work in an environment like this know the struggle of constantly trying to keep things from getting completely insane in terms of organizing. And I've tried to stay on top of it. I've been doing a little bit of the project storage organization lately, trying to keep on top of the ever-present and expanding mess that I exist in. And yes, it would be a full-time job to keep this place organized. Some people have that job. I used to know some people that would do that for government and otherwise. Like electronics shops, it's not an enviable position to have. It is a grueling amount of work. So I do as much as I can. All right, let's see if we can find. I think they might be in the surface mount organizers. I think they're at the bottom though. DuPont crimps, there we go. I don't know if I necessarily want to use DuPonts, but I would like something that crimps onto the end of the wire so that it doesn't fray and so that the screw terminal has something to push against and hold in place. Yeah, crimping is I have a tough relationship with crimping. It's a necessary evil. Because if you want to do things properly, you can't just solder wires down to everything. You need to have a wiring harness. DuPont clamps. What was the difference here? Why am I calling them clamps and not crimps? These are meant to go around a terminal, which is kind of weird that I would want to crush them. That's out of the question. All right, let's use these generic terrible ones. We're using stuff up with this project. These generally go on wires a little bit more cleanly too. So I take out exactly the number of crimps that I need for this because I'm definitely going to mess up. I mean, not mess up, because I'm definitely going to mess up. I mean, not mess up. So we want number 3. That in there till it catches. Start it off just till it starts to kind of, there we go. And that holds it a little bit more open when you've got one thing crushing it and it starts to kind of expand into the die. This one's ready to go. Let's get it on the end of this thing. And I put a Sharpie mark on one of the wires so that I know which one's which, where to plug it into the motor controller. I don't know which one's the upper and which one's the lower, but we can figure that out later. And then I got to go to this distance. I know it's hard to see the crimping right now. I just want to get this done instead of showing it on camera fully. How'd I do? How do I did? I don't know. I like to have a little bit of it sticking out of the front, but that does appear to be gripping the jacket pretty well. It's still gonna flex in ways that I sort of don't want it to though. So I think we're gonna take that on. I think I'm gonna clip it. So the stripe wire is gonna be the more clear one, and I need a better strip on the end of the wire. So what I'm gonna do is, I've got plenty of wire, I've got plenty of extra, so. Our friend has been collecting components for 50 years. I love the tour of drawers and boxes. Yeah, I used to do that with the science lab at school, is go through all the drawers and find all the weird stuff that's in them. Because there was some old science-y stuff in almost every drawer. It was awesome. I found TI 82 like lab kits that had like ultrasonic sensors and like temperature sensors and stuff. Is really cool stuff. But apparently you could use the Texas Instruments calculators as like lab equipment to collect data. That's a concept that's lost. Why no heat shrink? I mean, you know, heat shrink would be good and all. It's just a lot of trouble to go through. This is just speaker wire, and it's 2 wires that are held in the middle. So I just want to get a good cramp on it, so that I can put it into the screw terminal so that it will put enough pressure on the thing to make good contact. If it's just the wire, there's not enough wire for that screw terminal to kind of clamp down on. Really, the thing that I should be putting on the end is like a spade terminal, but those don't. They're all for larger wire. This is very small wire, so just putting the DuPont connector on the end should be enough that it holds onto the jacket of the wire and it keeps it from fraying if I bump into the wire a lot. I just messed that one up. Oh, you actually used those? I mean, it seemed like it was pretty cool. Crimping is tough. It's sometimes it's very unfun. Okay, after having guessed on that one, I think I messed it up. Damn it. I want the jacket to be a little bit forward, and then we can cut off the tip there and use the rest. But like that is making good the problem with it is that the end of the wire is very nicely clamped in, and so cutting it will make it a different length. Damn it, damn it, damn it, damn it, damn it, damn it. I got plenty of wire on the ends here. We're almost to the floating part of this whole thing. Because you are floating. Really, typically what I'm looking for is for the jacket to bump up against the crimp itself to tell me that it's at the right distance. That's the ideal thing, but sometimes you just don't feel it. Yeah, it unfortunately, until you get the technique correct, just gotta keep going. There we go, I can feel that. So now we can observe. Oh, come on. Really? You little bastard. Am I willing to accept this into my heart? My heart of hearts? I guess I'm willing to accept it, but I don't like it. There should be material on the other side of the crimp, because eventually this will start to slip out. You can see it down there, it's slipping out. And that will cause it to bend right here instead of bending the jacket of the wire. And when that happens, it'll eventually fray. See that? Boom. Instant. Whereas I could have done that for like a half hour if it was a proper crimp. So do it again. Again and again and again and again until you get it right. This drives me crazy. We'll get it. 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 We will get it. We'll get it. When we do, it'll all happen very quickly. Yeah, doing it with the singular crimp might actually be a much better idea. That's okay. So that is the first successful one. And so now it is gripping the plastic of the wire. And so when you bend it, it'll tend to bend at a much lesser angle. Sort of accept it. I'll accept that. I'll accept it. And then we got to do that 3 more times. Straighten that out. Usually give it a little twist just so it doesn't fray all over the place. What bugs me is when the other wire goes into a weird spot. That will not go in any further. That'll do. So I'm actually just going to cut off the actual DuPont part of this. It's just going to be that little crimped end of wire, and the screw from the screw terminal will come down on that. So just leave me with these. Just a weird little technique for a weird little project. Could you just use ferrules? I don't have ferrules that are small enough, and my crimper I don't think goes small enough either. Maybe if I tighten it up a little bit, I could put ferrules. But the ferrules also might not fit through these slots here, which is where these wires have to go through. So I'm doing it this way. This is a bit more minimalistic, but it's also exposed. So it's not really something that you would do in like a control cabinet. You would want to use ferrules because the ferrules have insulation over here so you don't accidentally short anything out. This is a low voltage project, so we can get away with something like this. We can get away with this kind of OSHA violating, horrible workmanship. But if this were like a brewing controller, I would not accept this. You could also put shrink wrap around the outside as well, yeah. I'm not going to go through all that trouble. I want to get this working before anything else. What the hell's going on with that one? It's all like weird and frayed. All right, try again. Try again. I guess the wire stripper must have taken off more than I thought. Really, what I should be doing is packing all of this electronics inside of the top piece, because this could be a much more elegant display. But at some point, I'm going to want to take this thing apart and make a laser speaker, an emitter array speaker. What's that thing called? LORAD? No, that's not. That's different. Ah, there's something in my eye. I love shrink wrap. Shrink wrap is very satisfying, but it can also be very annoying and time consuming. Not really time consuming, just annoying. I do like the heat gun that I have though. Although I'm tempted to look for a battery operated heat gun. That's probably not as good. But that way I don't have to go through all the trouble of fishing the thing out and then hooking it up to the wall. All right, so let's get these guys done. Butane, the problem with butane, the reason I don't like it as much is that when I use it, if you make one wrong move, it will burn up the thing you're shrink wrapping, or the shrink wrap itself will burn up. I've had that happen too often to really love using the butane. Although I guess if it was specifically a butane heat gun, it might not get up to the right temperature. 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 There are things you can 3D print too, and I'd like to explore that sometime soon, but if I explore that sometime soon, then that won't be working on Burn the Subs, and you guys will come down on me like a fucking ton of bricks for some reason. I'm not allowed to work on anything but things that are related to Burn the Subs. Anyway, if I were to work on something that wasn't specifically Burn the Subs at all points in time, and think about anything that wasn't Burn the Subs at any specific point in time, I would like to try to 3D print some helpers for the crimping tool that hold both the crimp and the crimpy in place and help me guide everything into where it needs to go. This is what I want them all to look like, but this one specifically was weird because I went past the crimp a little bit. All right, so let me trim that and we can finally be done with crimping. Crimping always takes way more time than I think it should, and I always end up talking about it the whole time because I'm streaming. And I get people coming in and bother, what are you doing? Why are you doing this? What is your problem? Why are you doing this, bother? And then some of them, they come in and they go, bother, wake up. Wake up, bother, you're in a coma. Your family is here, just please wake up. I don't know why they say that. Okay, let's see. I don't know which one's the top and which one's the bottom. Oh, yes, I do. So this one's the top one. I don't know which side, let's see. Making it exactly like they want me to. The top array goes into the side near the screw terminal. So this one goes in here. This one goes in here. It goes in here. I have been debating whether or not I want to buy a preamp for my lavalier microphone, my lav mic, or even just the AT4040 that has vacuum tubes, because I want to test what that's going to sound like, what a vacuum powered microphone is going to sound like for my setup. And traditionally I was critical of vacuum tubes. I said, you know what, those vacuum tubes, they don't lend anything to audio. We got transistors, we got plasma, we got ray guns, we got laser beams, we got sonic, subsonic, blow you away, woo. Sorry, those are aliens. Quote that I barely remember. Okay, but we got all kinds of transistors, right? I need to cut these a little closer because the screws aren't getting onto them. We got all kinds of transistors that can replicate all of the behavior of the old triodes. We don't need to have, you know, larger voltages and all this crazy fancy crap. But in order to make sure that I wasn't talking bollocks, I bought a tube amplifier for my headphones. And I hooked the thing up and I said, oh, I'm wrong. I'm way wrong about this, because it has a little bit of warmth to the audio. And I don't know how to explain it fully, because I'm not a huge audiophile. I know a thing or two about a thing or two. But in my experience, listening to the tube headphone amp, I like the audio. It sounds really nice. It kind of has a different quality to it as you turn it up. And so I think in order to color or shape the audio coming out of my mouth, it might be kind of cool to have a transistor preamp. It's like $100, so I will eventually get it. Hopefully I can incorporate it into the system, but that would be for one channel. So it's possible that I would get the $100 thing and then reverse engineer it, build my own into a box. I have plenty of tubes. I bought extra tubes at the beginning of the Russian conflict, because the tubes are made in Ukraine and surrounding areas. So I made sure to stock up on the wear and tear items for my audio system. Should have oomph. Well, so anything tube related that you look up, like 90% of it's going to be guitar related, because all the people doing stuff with tubes and guitars. So for my own purposes, I'm trying to look up like a high quality tube preamp for a microphone. And you don't really find high quality. You find like Johnny Electronics, barely related to guitar, simple transistor setup. And I don't want that. I want something that is like good audio, like really good audio. Because again, it benefits my stream. So I want it to be of the highest quality. So there's one that I can buy, and I think I'll eventually get it. And we'll see how that goes. Well, I don't see. You can buy studio quality. You can't find a studio quality schematic. That's what kind of bugs me. Is like, I am capable of building studio quality equipment, and I've got studio quality parts sitting in my bag of tricks. And in fact, building your own DIY audio means that no bean counter has been through all of your op amps, and you can use nice low noise op amps. But the circuits that you find are all Joe Scrub's first attempt to solder something with a transistor. And you're like, Joe Scrub, I like what you're doing, but I need something better than that. It would be kind of super duper awesome if I could DIY all of my sound stuff, but time is money and all that. And also, when you DIY something, it's just this big house of cards. And when you're streaming, the project is here, not my microphone. So I got to pick my battles. But I think what I'm going to do is buy the tube unit and just put it into the line, into the microphone line, and see which one I like it on. If it's the lav mic or if it's the actual mic that I use for gaming streams that I haven't done in like 4 years. God damn it! Where does the time go? Next time I do a gaming stream, I use a microphone that's on a stand, and it's an AT4040, so it makes really good replication of the sound that's in the room, any of the sound that's in the room. So having a preamp on it might widen the my voice tones. Abiotic, please. I'm debating. I might, maybe soon. Okay, green laser there. Power supply. Well, for now, they want you to start with below 9 volts. I'll eventually find a normal power supply for this. Abiotic factor is like Half-Life 1 survival horror game. Sorry about the burp. You should check it out. It's basically a crafting sort of horror game, exploration game with just a 10 out of 10 map, and the concept of running around in an office and gathering supplies in order to kind of hull up for an extended campaign against an invading horrible force. It's a very well put together game. It was made in New Zealand, and it's super cool, and the devs are like right on top of their game. It just came out with 1.0 a week or two ago. The staplers are extremely important in that game, and they should be gathered with care because you kind of run out of them mid-game, and it becomes an issue because every crafting recipe uses a bunch of staplers. Okay, we are getting ready to test this thing, this hovering nonsense device that I built so long ago. We are actually going to be able to test it. So what we need to do is load their code up onto the microcontroller and just give it a quick little test to make sure that it works. So let's put their code into this jimmy jam, this little jobby over here, and then we can test the 3 switches to make sure that they work properly. Which means I probably don't need channel 2. We can just rely on looking at channel 1. And, well, actually, no, it's fine. That's fine there. Oh, here's my button pusher. Oh, that's right. Okay, so this is my button pusher. Oh, did the jitter change when I changed the button around? No. No, it did not. Oh, yeah, and then the scope. Scope. There it is. Okay. Jittery. So I'm going to go into Arduino and I'm going to open up this little jobby right here, their code, all of their stuff going on where they program things in the way that I don't prefer, which makes it a lot less modifiable. But I am just going to, the tools on the board and the COM port are all still recognized. So I am just going to upload this code and you will be able to see when this thing comes back to life, the difference between my code and their code. Damn it. We'll be able to see the difference between... Oh, it's still compiling. Hold on. We will be able to see the difference between my code and their code. And their code. And their code. And their... There it is. Where did the jitter go? There's no jitter. What the heck? So on analog... Or no, on digital... 3, 4, and 5. 3 should move it in one direction. Huh? Okay, where's my input pull-ups? Hello? Why you not move? Why don't you not move? This is on ground, and then it's 0, or it's rather 2, 3. All right, 4, 5. Yeah, I'm playing through the game, but I'm playing through it very slowly. Oh, this isn't the channel that moves. This is the one that moves. I'm the one that moves. Wait, so that channel is there. This one is here, and here, and here. So now one will move out of phase with the other one. One will move out of phase? No. What the heck, man? Those aren't the same channel. Those are 2 different channels. There we go. Okay, so that moves one way. That moves it the other way. And then that one resets. So reset, one direction, other direction. Reset. Reset. Did I skip 2? Skip 2. Yeah, reset. So yeah, those just move it in and out of phase. And this would be much simpler for me to do on a slightly more powerful microcontroller using audio tools. I would be able to do that pretty easily. With the ATtiny, the Atmega 328P, I can't quite do that as easily without doing what they did, which is using machine code to get into the PWM engine and assigning it to different pins and all that stuff. So they've done it their way. I don't prefer to do it that way because their microcontroller code is far less easy to understand and manipulate. For instance, oops, I soldered to a different digital pin for the button. I should be able to just go into the code and change the pin. But unfortunately, that is not the way that this thing works. So, okay, I'm confident enough in my soldering that I think that this will probably successfully power the project without blowing it up. And so I'm going to risk my hardware and just go along with it and see if it works. But Bother, you said that this project was specifically to use up hardware. Oh yes, as if blowing it up wouldn't also be on my agenda. No, but this thing is simple enough. It's like 5 volts and ground. It's not that complicated, so this should work on the first try. So the programming pins go out this way, and then we can double back modify our code in order to work on this system and see if it has the same performance with all the jitter. Why isn't this plugging in? That's because I need to put a lot of pressure on it, and the 3D print isn't allowing me that pressure. There we go. All right, so there's our levitation machine, a sans laser going through the whole thing. The question is this going to work? I need that adapter. So I have one of those barrel adapters that just goes out to wires somewhere. I don't know what happened to it. Oh boy. Is you it? No. I wonder where that adapter went. I had it all coiled up, stored somewhere. I don't know. I'll probably run into it one day, but I guess in the meantime, maybe we can just use a wall wart on this thing. Should have a wall wart that goes down far enough. I think I have a 9-volt one sitting over here, actually. 5-volt DC, no. This one's 12 volts. Maybe we'll just go straight to 12 volts. 12 volts, 200 milliamps at 12 volts. I don't know if that'll be enough. Let's try it, though. I like to use the adapter because then I can tell how much current through the power supply it's using. My power supply can, of course, handle tons and tons of current, but you know, you kind of know what range it's in. We're going to use the 200 milliamp wall wart. I don't think it's going to be enough, but we'll see. We'll find out one way or another. This should be off. Please don't blow up. Please don't blow up. I'm going to blow up. All right, so if you're doing a project like this, the initial power up is very important. Let's turn the scope off on the screen. What I'm doing right now is the wrong thing. I am powering this thing up completely right away. That's not a good idea, because if you happen to have just a little short out, or if you happen to, you don't want to use a little 5-volt battery bank. They encourage you to start with a lower voltage and ramp it up, and that's really where the bench power supply comes in handy. I could start this at like 3 volts or 6 volts probably for this thing, so that the voltage regulator in this thing is able to produce 5 volts for the rest of the circuit, right? This thing is running at 16 megahertz at 5 volts. We need 5 volts in order to power up the project. So starting at 5 volts means that this regulator doesn't have anything to regulate, and so it might not work, especially if it's a cheap one. Giving it like 6 volts would give it enough volts that the regulator would be doing something, the microcontroller would be doing something, and then all the ultrasonic emitters would maybe be doing something. I am giving it 12 volts right off the bat because it's stupid. I'm going to do that because it's stupid, and we do stupid things here because we can. This might get hot. What's going to happen is this is going to have a particular current draw in order to run the whole system. That current might not be enough to get all of these transducers to run simultaneously. So we might dip. Our current might dip. Our microcontroller might dip because of it. There could be all kinds of unforeseen consequences of having too much power drawn from this. It might heat this up over time. If we're at something like 300 milliamps, this thing will gladly take 300 milliamps. This laser at 5 volts takes 300 milliamps. At 12 volts, it's going to take a lot less. But still, there are, some concerns with the low amount of current draw that I'm going to get from this thing. And in the same vein, this probably doesn't have as many protections as a more professional power supply. So this will try its mightiest in order to give the amount of power that's going to power our project. If we're lucky, we're going to be below the 200 milliamp line. We're probably not going to be lucky. It's probably going to be above the 200 milliamp line. We might see things heat up. We might even see something rapidly heat up and explode, but I don't think that's really going to be the case. I think we're probably just going to see this thing try its best and possibly fail because it doesn't have enough current. So again, if we were doing this professionally in a workplace, we would hook up the barrel plug to the power supply over here. We would run the power supply at a very stringent current limit at first, up to 5 volts, maybe give it a little bit more current authority to figure out what the current draw is, and if it's not excessive, we would go up in voltage until we hit 12 volts. And you could see all the stuff that you need to vet out and correct. Anyway, let's do the dumb thing. 3, 2, 1, go. Yeah. Oh yeah, the switch is off, so 3, 2, 1, go. Nothing is heating up. Thermals work? Thermals work. Nothing is heating up. And the LED over here is not turning on. There should be an LED over here that turns on when this thing is powered. Try the laser. Nobody's doing anything. Is the barrel not connecting? That's a pretty solid barrel plug. Let's check for 12 volts. 12 volts, 200 milliamps. Yeah, it's pretty loudly silent right now. Okay, no voltage there. Check the barrel. Negative 0.28 volts. Huh? Oh, we got a dead power supply, so we got a donor for our adapter cable. Huh. That's nice. Wow, that is a dead plug. So I'm testing directly on the plug. I'm getting nothing. Cool. What happened to you, bud? Maybe it's connected weird. Hold on, let's switch it around. This is getting into a dangerous zone where this might be a bad capacitor scenario in a sealed power supply. Yeah, 0.28 volts. That's okay. All right, well, we got a donor cable. Now we get to do things the proper way. I'm gonna put ferrules on the end of this wire. So what the heck gives, ICOM? You did. Huh. That must explain why my radio's never charged. I think this is the power supply for the radios that I had. Well, it's dead, so we're not gonna stand on ceremony here and just clip the bastard, throw it out. Okay, that ended up in the recycling. But I mean, I'm not gonna suffer to figure out what happened to that thing. I don't care. The last time we had some weird power supply issues was with this thing that I had under my desk that would make sure that the fans were blowing. There's like a little fan controller that I built. Cool project, but it's totally useless now. Anyway, when I had it, when we had problems with it, it would do weird stuff and reset weird and had just sort of a weird relationship with power coming in. And it turns out it wasn't getting good ground. We took apart the wall wart and all the capacitors inside had exploded. And all of the exploded capacitors had capacitor juice all over the place. It was nasty. I'm gonna put ferrules on the ends of this, which is a different crimper, but it is also a very useful crimper. This is the ferrule crimper. It is a savage little thing that you should not put any appendages into. And we use that on ferrules, which are these little wire thingies that go around wire. Hold on, where's the ferrule kit? F-E-R-R-U-L-E. There are a lot of letters in that word, ferrule, for a word, a lot of words, a lot of letters that you just don't pronounce. F-E-R-A-L is the better spelling of feral, but that's like something that's wild and untamable and not a little thing that you put on the end of a wire. Say the warning from experience, yes. I've been around the block. It'd be nice if I could put 2 different crimps on for the different color, but the crimps are color-coded by size. So I have 1 size to put on that thing. And it's fairly thin wire, so I don't know if it's really going to take, but we'll see. Yep, need to expose a little bit more. This is fairly low current wire. Not a lot of stuff here. You can get barrel connectors with much more, but this is just what we have. I guess you're not supposed to twist the wire. I twist the wire. I twist the wire. And then we tighten this one up a little bit, so hopefully it'll fully clamp down. Yeah, pretty good. Okay, cool. That should hopefully allow it to last. That should allow it to last a little longer. I'm saying hopefully too much. I'm trying to say a little less. Repetitive language ticks. Yeah, pretty good. All right, trim the end. Actually, really what I should have on the ends of these is banana plugs. The banana plugs will allow me to put it in, just plug it quickly into the power supply. But I can use these with the screw terminal, that's fine. Let me just get these wires to the side. Power you up, and let's find out which one is the stripe. Which one are stripe? Typically, well, actually, no, I don't know what's typical in barrel plugs. Which one is typical of stripe? Is stripe always ground? So the outside of the barrel to stripe. I wish they molded the labels so that it would tell you. Like they do on the computer power supply plugs. So stripe is the center. And the center is positive power on typical barrel plugs. Although I think, what is it? Japanese barrel plugs do it differently? I don't know. Some companies do it differently and it's annoying. Okay, so the stripe is center, which is positive. So go over here. These have a big hole in the side of the terminal. When I built this power supply, I made sure to accommodate all these things. So that can go like this. I think putting banana plugs on these would probably be a better idea. Because then you just shove it in the front of the power supply. You don't have to find the little ingress hole that these have. These are from Easy Hook, which is an American company. They make really good terminal kind of stuff. Yeah, you know, I'm rethinking that adapter. I think maybe I want to put banana plugs and shrink wrap on it. Although the banana plugs that I have that fit into these lab-sized ones are way too big. All right, so let's start at 7 volts and just see if this thing works. So power supply on, this thing off. Off 1. Plug that in. So we have to power the whole thing before the laser will light up. I can't just light up the laser independently. So we are going to observe on the infrared what's going on with these two. If the chips light up suddenly, I'm going to turn it off again. Yeah, well, the screw terminals are okay. You can get from Easy Hook, you can get banana plug stuff. So like these guys here, and that'll just go right in the side. Using screw terminals, like even with the ferrules on this, it's a little bit weird. Whatever, it is what it is. Let's power this thing up. 3, 2, 1, go. Okay, all the LEDs turned on. Of course, we can't see anything. We can't hear anything. Actually, I do hear a little bit. But then what happens if I power up the laser? Nah, I got a good laser. This will also heat up. Yeah, the banana plugs that I have are also solder, and that requires a huge solder cup. And it's like a big plug. It's a little bit much to deal with. I think I've run out of that size, though. I might be out of those. I think there are ones with just like screw terminals on them, so you could just screw the thing into the end. Let's get a little piece of styrofoam and see if we can't deposit it somewhere in the path of the ultrasonic emitters and float it in the air. So maybe I need long tweezers for this. Where are my long tweezers? Like the long tweezers. I don't think I have them. All right, let's just use normal tweezers. Normal tweezies, and let's see if we can get this thing floating in the air. Now, I don't have the laser to help me align it. The laser's a little bit bright. I would like to dim that laser, but I don't think I can. Oh, and then my tweezers are sticky. I mean, I definitely hear something happening inside of this. What? Floating in the air. Beautiful. Isn't it creepy? Too many wires in the backsplash. And again, like this is a sudden thing that I wanted to build real quickly. That's why it's not really done all that professionally. And all the electronics are sitting up top like crazy. Burn the witch! He's using magics that are unknown to man. Yeah, so the, what do you call it? Oh yeah, and the buttons. I can move it in the air. Oh, that button doesn't work. Reset. Oh, it's not. Okay, that's in a side channel then. Whoop, we lost it. So this thing still works. Cool. What are we working on next? Bother, why don't you freaking get anything done, you stupid streamer? I hate you. There we go. Look at it go. This is all it does. This is all it does. It just suspends stuff in the air. I told you I knew what I was doing. You didn't listen. You didn't listen to me, and now what? Now you reap the effects of dabbling in super science. All right, let me clean up some of the shit that's in the way. There's stuff all over the place. I know Joe Apple will be very disappointed with me. What is this design? I can see wires. So this is their design, right? And it's hovering this thing right there in the air. Look at that, right in front of me. Imagine being some kind of nerd that actually makes something that denies all known laws of physics, invalidating decades of research and knowledge in seconds. It has happened before. Well, this is not that. This is me finding something cool on Instructables 5, 6 years ago, putting it together for stream, showing it off, giving it the ooh-ah for about 10 minutes until I go and work on something else infinitely. And so the impression from my viewers is that Bother never gets anything done. So I found this thing in a pretty sorry state at the bottom of the bins of projects and decided, you know what? I was moving towards making this thing more professional. Why don't I make it less professional, but also still functional? So instead of making it nice and packing everything into the top and the bottom like I wanted to do, we put it together with wire wrap and some Amazon parts and some just cheap stuff in order to just get it together and make it look like something that I would have in this shop. And you know what? This is a better result. This is a more relaxed thing. I didn't have to worry about packing the wires in and making sure everything was perfect. And I think it turns out pretty good. It works. It just works. It doesn't really have any additional features. Now, the question is, my code versus their code. And we saw it earlier. We saw the two different waveforms from both my code and their code. I'm going to turn off my scope while we oogle this thing. And what I'd like to do is load my code into this thing and see whether or not it still functions, because my code had more jittery 40 kilohertz waves. So I'm going to go back over to here, and we need to do a couple little programming things here. I'll let you guys look at the the levitation, the evil dark magic. Where is that? There we go. You can observe the evil magic of levitation with the single kernel of whatever that stuff is. Where's my focal point? Am I focused? Hold on. Oops. Oh God, we're not focused. In the research paper, they also levitated an ant, which I thought was pretty unethical. Was going to stream this weekend, but conveniently the package that was supposed to come 2 days ago with my mic has been marked as delayed for 2 days with no updates. Oh God, that sucks. Yeah, get the microphone in, but definitely do like a shakedown run on your whole stream where you record a little bit and then listen to it back and just see how the audio levels are and how everything kind of comes together on screen, because that was a little bit eye-opening, is taking just a little tiny sample of my own stream and taking a look at it and going, oh God, I'm terrible. So we need 4 note players. So instead of an array of 2 note players, well, actually, yeah, we need 4. We have an array of 4 note players, and then we've got note players 0, 1, 2, 3, and 4. I guess I just need to initialize all of them at 40 kilohertz. I don't know what this is going to do for the program, if it's still going to work. And then the delayed one, we're not going to put in. We're not going to delay. We're just going to doot. And then I'm going to have 0, 1, 2, and 3. So A0, A1, A2, and A3. This is going to maybe not work. I don't know. This might not work. Oh, that's not what I wanted. Oh, I wonder why it's 0, 0. Delay microsecond, 0, 1, and then 2, and then 3. So this is literally just going to output a bunch of waves, but the thing is, note player 2 and or actually 0, 2, 1, and 3, because these need to be 180 degrees out of phase, which I think is 10 microseconds. So we'll do that and see what happens, if it's even capable of doing this. And we could actually take the button stuff out of the loop, and that might de-jitter it a little bit. But I'm going to keep that in there just because it's funny. And then our buttons are 2, 3, 4. And let's just see if that works. So we're ready to go. I just need to plug this thing into the programming thing. I can't believe that just worked right off the bat. It's really weird. Why isn't that actually plugging in? Hold on. Before I totally disrupt this thing. I hate these cheapo Arduinos because you got to plug them in upside down. Okay, upload the code. Our floating bead is probably going to fall once the code goes in. So compiling. Yeah, I can perceive there's a very high frequency squeal in the background. Problems uploading the board. Oh, I need to actually be able to plug this thing in. There we go. Upload. Smell. Problem uploading the board. Oh, you know what? It's because it can't affect a restart. So we're just going to have to... This can't do a restart because the board is plugged in. So we'll power it off. And then the styrofoam falls. And now I think I can... Let me make sure that the port is there. Oh, it's also switched to COM4. What the... No, COM4 is not right. This thing isn't powered up properly. Hey, bud. Huh, no COM port. What's going on? Port, there it is, COM6. Okay, now we're connected to that. And I think I can plug this thing in like this. And I can click upload. Okay, here it goes. Silly Arduino stuff. Uploading, 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 verified, and done. So now we've got my jittery signal. I'll grab this down here. Grab my little piece of floaty stuff. And I will power this thing back on with 12 volts. I don't know if I can hear it. Oh, I think it's working. Nope. Uh-oh. It does not appear as though it is working properly. Of course, it doesn't help that these tweezers are a little bit sticky. Let me get a non-sticky pair of tweezers. No stick tweezers. Ah, there it is. Oh, these aren't the ones I thought they were. Excuse me, sorry for the burps. Yeah, it appears as though my waveforms are either too far out of phase or just not. It's probably the jitter. It's probably the jitter causing issues, not causing as much of an interference pattern in the middle. So my code does not pass the smell test. Oh wait, I need to plug this thing in for it to upload. Hold on, AVR. No, bro, don't do it. Oh, it already failed. Wait, it says it's uploading. It says, oh no. I missed it. The selected port does not exist. Yeah, it does. Upload. Haha, I can gaslight my own programming software. Check your program. You're not initializing the right channels. Boop. 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 You're right. 2 and 3. 0, 1, 2, and 3. And then that might... So, okay, so half of the array was off. Let's put this code back up. We'll see whether or not my... Because there's a lot of jitter due to the extra microcontroller stuff that we're asking it to do in the Arduino realm. And actually, technically, I think one array should be enough to hold up a piece of styrofoam. Oh, there's an audible squeal coming from this. Oh, I can hear it. I can hear the squeal. I don't know if you guys probably can't hear it, but it's like the teenager alarm. Beep. You can see it kind of deviated over this way. You can hear it? Oh boy. Yeah, I think my code just isn't locked in. It's going to be like one of those ultrasonic injectors. You can see it kind of like moves the styrofoam around a little bit. Like there is a pressure wave front inside of this, but it's not enough to float this thing. So, all right, so let's get rid of the... You guys can hear it? Okay. Turn that off. Oh, wait, that was off. Wait a minute, now it's on. Oh, I wasn't feeding it 12 volts. We didn't have enough voltage. That was running off of USB power. It's just not doing it. Woo. Okay, let's get my code back in here. Or I mean their code back in. That's true. Right now it is getting 7 volts. But I don't want to give it more power because mine is making an audible squeal, whereas theirs is inaudible. Okay, so there's their code in this. And then if I power this up, I can't hear it. I hope you guys can't hear it. And then all I need to do Oh, come on. We are powered on, right? This is drawing 0.5 amp at 6 volts. Did I just get really lucky the first time? There it is. Anything heavier than that will not hang in the air. I can do drops of water. I need to go get a syringe in order to do that. So we'll do drops of water next. We should get the laser working too. What's up, Haystack? How you doing? Yeah, it is a magic levitation device. Look at this science going on right now. I love science. Their software is running that 40 kilohertz tone a lot cleaner than ours does. But yeah, a floating piece of styrofoam and anything requisitely tiny and light I can float. I'm floating. Other pieces of styrofoam. Nope, lost it. Nope, nope, put my hand in there. Too big. This is too big. See, even this is too big for it. No, it can't do stuff like that. This is a very weak field pressure wave. Very weak. We can use the buttons to move it around a little bit. Or just lock it in place. Need to go bigger. I can't. This is the look. You don't understand how incredibly weak this is. Now, the thing is, like, I could probably get a little bit more power out of this if we were able to tune it properly. Most of the ones you see have an adjustable side where you can adjust it up and down. Is it safe to be around? Yeah, it's safe to be around. It's just ultrasonic frequencies. It's not heavy. And then the other thing, let's up the voltage here. Right now we're at 7 volts. So let's go to 9 volts. Of course, at 9 volts, I'm starting to hear it a little bit more. And we don't really know what the complicated pattern of interference is in this. I want to view one of these with a Schlierinen viewer. One of those concave mirror viewers that allows you to see minor air currents. Whoops, I messed it up. Oh, come on. Give me this. No, give me this. Give me this. No. Come on. Gotta work with me a little bit here. You know, the fan is on behind me. Maybe that's affecting it. Yeah, it's a little chaotic in the middle. I'm not having very good luck. Stop breathing on it. Ugh. Its floating is based on movement. Ugh, come on. You little bastard. What is... So the laser helps with this. I should probably put the laser into this so that we can ascertain where center is. Ugh. And then sometimes it just works. In high doses, can it cause tissue damage and affect heart rate? Maybe you're not going to make this into a weapon. I don't know why you're fixating on that. This thing is safe. It is just a distance finder. Yeah, it's just the same stuff with sound in general. It does make a bit of a squealing noise, but it's nothing more than, you know, a CRT makes. It is a little bit more than a CRT, but it's not like debilitating. I'm sure Willow probably hates it. The dog, that is. Yeah, this is literally just air holding this thing up in place. It's a ultrasonic pressure wave front that is interfering with another one, and it makes high and low pressure areas. And so we are sort of balancing this piece of styrofoam on top of that. But, you know, even my slight interaction with the waves in the area are going to change that interference pattern and start to affect how this thing is sort of in the balance. The little bit of jittering you see is from either me waving my hand around this thing or from minor air currents caused by the fan that's on me. I always have a fan on me when I'm streaming because it's hot in here, and luckily you guys can't hear it. I can hear it in the recordings and stuff, but yeah. It'd be better if there were mirrors. Well, you can't get sound through mirrors. I wonder what happens if I like puff glitter into this thing. I'm not going to do that. So, I mean, save for the one feature of having the laser go through the middle that helps you kind of align everything. With the laser, it looks actually really cool because then you get a clear thing in the middle. We'll work on that eventually. It's just for right now, we've got a thing that's able to hover a very, very light piece of styrofoam. I mean, look, they didn't blow up the academic world by writing the paper on this, but they did uncover a cool thing that you could do with a bunch of ultrasonic emitters, which is to float stuff in the air that is visible. The very minimum requirements of being able to do that. And the things that you float need to be incredibly light. But again, there are these weird channels where you can find low pressure. I'm trying to get like a good backdrop on this so you guys can actually see the stuff floating. Something that's a little bit less busy. Ooh, it's three-dimensional. Yeah, next we're going to do a Star Trek tractor beam. And then we're going to start up Tractor Beam Supply Company. Sticky tweezers again. Get off of my tweezers. Damn it. There's like static electricity holding it to the mandibles. Nope, I think I need a lighter piece. The end game is that I'm going to blow up a human with it. I mean, you're looking at the end game. The researchers would have to figure out more stuff that this thing could possibly do. I don't know. There's probably microfluidics that you could do with this thing or some other branch of scientific stuff. But practical applications, no idea. I made the joke before reading the screen. Ah! What was that? Lunatic Live is rating with a party of 25. Louie, how's it going, man? I've been trying to keep up. Ah, shit. I just lost something. This is an ultrasonic levitator. It is somebody was asking, what are the practical applications of this thing? And I'm like, I don't know. I don't really think there's practical applications in something like this. This is a silly little, I need a tiny middle finger. I mean, I've got a slightly larger middle finger thing, but it won't float that. This is a thing that I made in my garage. No, this is the thing that we made in the shop a long time ago, and we just now got to actually making like a controller for it. I was originally going to pack all the stuff in the base so that it looked like a cromulent piece of equipment around here, but it ended up in project storage, which netted it completely broken. So we took the glue gun out and I fixed the upright supports, and then we did a little bit of soldering and a little bit of coding, and it actually turns out just using the code that they provided would be the ideal thing to do. This Arduino here is basically outputting a 40 kilohertz signal into a motor controller that then drives these ultrasonic emitters. And the ultrasonic emitters are putting out a very high frequency indeed. It is just barely inaudible, although I am hearing a squeal. It's just barely inaudible, and it is creating a pressure front, because a sound wave is just a pressure front, right? And so if you have sound waves going alongside sound waves and they are in sync with one another, they will create a larger sound wave. If they're not in sync, if they're out of phase with one another, they will create a smaller sound wave. And so the interference pattern of these expanding waves creates high and low pressure zones, to the degree where you can float a little piece of styrofoam in that pressure wave. And so we've got floating pieces of styrofoam, because you are floating. And I'm gonna flush your ass. One of my favorite hackers quotes. Yeah, so it's a bunch of ultrasonic emitters. It's in an array. The original project that I wanted to do, because this is the same technology behind those laser speakers. The laser speakers are a flat array of ultrasonic emitters that you feed audio into with like a high frequency carrier or something like that. And so these pressure waves go through the air, and in sort of linear fashion in front of the speaker, you can hear somebody's voice. So you can talk to just one person and go, hey, what are you doing, buddy? And they're like, do you guys hear a voice? And nobody else will hear that voice. Taking that along with the principles of the spy microphone, those dish microphones where you can listen to just like one person in a crowd, and a slight audio delay, you could hook one of those dish microphones up to the laser microphone, and somebody who's like giving a speech or talking on a megaphone at a festival, you could point that at them and they would be like, so anyway, what I was saying is, wait a minute, why can't I hear myself? And like shut them down. I think that would have been hilarious to build. I was gonna build that, but then I decided that floating pieces of styrofoam was somehow a priority, and so that's what I ended up building. Yeah, I think there's applications for something like this in industry, but it's in a corner of industry that I have no idea. I have no idea about what those crazy scientists are doing with their microfluidics. Yeah, pretty cool. Wait, why is the laser turned on? Wait, why is that happening? Wait a minute. Why did that happen? Oh, the body of the laser was hitting some metal? Oh, whoa. That's not good. Apparently the body of the laser must be positive power, because it's turning on when I hit it up against sort of the exposed power lines over there. Hoverboards are going to be loud as fuck. This thing is making a slightly audible squeal. I could not imagine if it would lift my fat ass any significant amount, how much energy would be coming out of. I'm trying to focus on the styrofoam there. You could make lamps that can levitate stuff. They already have those. They use magnets. They look much cooler too, because they have the magnet like pulling against itself and like floating in the middle. And then when you want to turn off the lamp, you just break the magnetic thing, and it just falls. I think those are cooler. But I don't know what kind of emitters you would need in order to make this thing more powerful. Float a drink into the living room, and all the dogs in the neighborhood start barking. Yeah, which ones are those? As the motor, the magnet phase goes around, it makes that weird like it's a weird motory noise. It's a cool noise. And that's, what is that? Is that Hyundai or is it Honda? Whichever company does that. We have one in our neighborhood too. And when they pass by, I'm like, the future is here. Making me think of Bewitched. Listen, floating technology, like floating stuff in the air, is not as easy as media would have you think it is. It's a big conspiracy. Hoverboards and hover packs. Yeah, I guess that's right. It's not like a completely silent electric car, so it's not going to suddenly run over your dog. But still, it's a weird noise for it to make. It's like the real future noise. So this thing is only good for pieces of styrofoam and droplets of water. When we did droplets of water previously, it was kind of cool because we had a laser beaming down, and it was my other green laser. I actually went on Amazon and I ordered this green laser, but I think it's too powerful for this. I think this is too much green laser. We'll maybe work on that in the future. For right now, I'm willing to just call this thing done and move on to other projects. Move on to other projects, because we got to get Burn the Subs back up, because that's going to be my foyer into the Twitch front page. I am going to apply for the front page at some point, and at that point, I had better be ready to have my ass with a big project complete. So Burn the Subs is sort of going to be the focus for the next couple of weeks. I'm going to kind of hunker down and work on Burn the Subs and, you know, try to get my life together. But I think the only way that we're going to be able to generate more viewers this day and age is if we hit the front page, like with our hand, and also have a really cool project going at that time. So when we put together Burn the Subs, I don't think I'm going to make it for September. We've been working on this thing for years, right? It's going to need some very specific attention in certain areas. So the next thing we're going to focus on is LEDs. I want to get LED patterns running from a Raspberry Pi. Next, Burn the Subs on Node-RED. I can run Python scripts in Node-RED. So if we can get that running, then we can get the database entry system going just as a script on another computer. So it was a 2-month project. The original one? I don't think so. I don't remember how long the original one took for me to make. Oh, the redo? I don't think I ever put a timeline on it. I wanted to get it done in 2 months, but it became a lot of work because there was a lot of stuff that needed to be addressed. And now that I've got all the capability, we've been putting our best foot forward in terms of being able to do the cool things with Burn the Subs that I wanted to do. Quality of life stuff and whatnot else. How cool is that, though? So this is one of those things where you look up a project on the internet, you buy a bunch of parts for it, and you start to get your butt together for making one project, and you discover, oh, there's this different project that I could do, and I have all the parts. It's for that other project. So you put that one together, put it away. It's broken for months and months. You bring it out, put it back together. Look at that. It's a cool thing that levitates little pieces of styrofoam on your desk. It probably also pisses the dog off because this cannot be quiet on the frequencies that she can likely perceive. But now that we've gotten it together enough, I am willing to put this back on the shelf and we can work on other stuff. And then, you know, on a rainy day, we can take this thing out and say, hey, this is some stuff I wanted to do with this little floaty McGee kind of thing and get it running. But yeah, cool stuff. Louis had a perfect time to raid because we actually completed a thing. And it turns out one of the big lessons from this project is that trying my own code didn't work. There's a reason that they went all the way to doing machine code on this thing, and that was to make all of the emitters synced up enough so that you get a consistent interference pattern. Yeah, put it on a shelf until it breaks and then try again. So it looks like I need 9 volts at about 600 milliamps to run this thing well. The question is whether or not this thing will suck more than 600 milliamps out of something, but right now we're running 9 volts, 600 milliamps. So that's the number that we needed. Let me actually write that on the top for future bother so that I know what I'm doing in the future. Makes me look smart. So 9 volt, 600 MA. And as long as I don't so much as put a finger on that spot right there, that should stay. Unfortunately, Sharpie pen on a 3D, especially on PETG, just doesn't stick. It just doesn't stick. Look at it go. Now, it's not completely agnostic of gravity, but it can work at a variety of different angles. So, pretty cool stuff. Look at it go. Yeah. Unfortunately, there's not much cooler that I could... Actually, when I invert this fully, those pieces of styrofoam are going to fall. Let's see what they do. Ooh. Ooh. No, it didn't catch them. I saw on Thingiverse somebody had one of these that just had a handle out of the back, and it only had one of the arrays, and they called it a tractor beam. So I don't know to what end, like if you didn't have the second array. But if I put my hand in the way, it will not, it won't float these. So I mean, if you had pieces of dust that you wanted to move around, like maybe this would be effective. Remove solder balls from PCBs. You saw how much it struggles with a piece of styrofoam. I think you're overestimating how much weight a piece of styrofoam really has. I mean, it's all well and good to be able to manipulate it like this and move it all around, but we're talking balls of styrofoam. But on that level, I mean, there are fields in science where you need to manipulate something that's as light as a ball of styrofoam or a little tiny drop of water. There is an entire field called microfluidics that could potentially have application in. Now, keep in mind, this has been around for a while. We built this like 4, 5, 6 years. Oh God, this is a pre-pandemic build. So we built this a long time ago. This technology has been around. It's been around. It's been around for quite some time. So if they were going to do something smart and cool with it, they probably already have. All right, I think that's it for me. We're gonna chalk this one up as a win. Someday we will drill a hole in the top so that I can run the green laser through it, and then we'll do droplets of water on this. I can levitate a drop of water, and I've done it in the past. I don't want to do it because I don't have a syringe ready. I don't want to run to the bathroom and fill a syringe with water just to do the droplets right now. We'll do it another time, I promise. I'll definitely make sure you're not around when we do it. Thank you for the raid, Louie. Thank you for subs and everybody. What are we doing right now? We got a bunch of viewers in here. We're looking pretty good. Is anybody else around that I would want to raid? That's a short list. Oh, really? What's Milton still doing? He's Battlefield. Everybody's doing Battlefield. I'm glad you guys could join me for that because that was a rare bother completes something. Wait, why can't I expand the menu? What's going on here? Twitch. Just try not to break yourself. Polarin's doing Valheim. Okay, no, nobody else is on that I would immediately want to raid. Rare bother W. Can you guys maybe not just repeat my self-deprecating jokes? It's my fault. I shouldn't have made the jokes. Makes me feel bad. But I actually was able to get, can you raid BitLooney? You know what? I'm just gonna stop the stream. You guys can go watch BitLooney. I am going to go touch grass. I would suggest you guys do the same. It is going to be a heck of a weekend. I don't think I'm gonna be streaming much during the weekend. If I do go live on Saturday, maybe I could do gaming, but I'm just not hooked up. I'm not connected. Ew, touch grass. Go touch Grassington. Go do it. We were able to get out of here in kind of a short amount of time. We got everything that we wanted to get done, and I've got this thing that can now float stuff. So, you know, maybe if somebody raids my channel in the future with like a big crowd, we can bring this thing out and I'll have a project that's physically very cool to look at that I only need to do some very minor things to in order to bring it into the next stage. That's kind of the idea. That is, I'm showing you guys how the sausage is made. That's kind of the idea behind this. Do you even have a gaming PC? That was a big project on the stream. I water cooled everything I could. I used some of those 1/4-inch silicon rubber tubes and some copper tubes and a nickel plating process in order to create some, some small water channels for the M2 memory, and my RAM is also water cooled. We had a great time with that. We went crazy. The only problem with the computer now is that there's a high spot that's above the reservoir, and so bubbles tend to pool in that tube, and every now and then I got to do the computer dance and get the bubbles into the reservoir so that I can add water to the system. So that's something I'd love to correct one day, and also put a 1,000-watt power supply on the thing. But anyway, that's not today. That's not today. We will come back Tuesday, and I will work on something related to burn the subs, now that this can be put on a shelf in a semi-completed state. I don't think I'm going to put it on the shelf powered up, though, because there's a minor high-pitched whine that I can perceive from way behind it. But Burn the Subs is big and cool and working. But Burn the Subs is not working. We will get it working. We got to work on it. All right. The end card, if I set it up properly... I didn't set it up, did I? Did I set it up? The next one being on the night... Yeah, I did, actually. So I am bravely going to put the end card in here. Boom. And there we go. 3 days, 20 hours, 6 minutes, 38 seconds. Oh, that thing's back to doing the exact time. I must have been so close to the hour that one time, because it said one time it just said 20 hours. So I must have been close to the whatever the limit is on that. I should put this in something that like a tourbillon mechanism that would like spin it in cool ways as it's floating the thing. It's like a space station. Because it is kind of cooler when it's like this. That'll be, so for another day, here's a project for another day, putting a tourbillon mechanism with this thing in the middle. That would be really cool. I lost power at the house, and when I finally get it back, the stream is over. C'est la vie, such is life, I'm sorry. I cannot permanently stream. I'm not Uo's Lab. I don't make a lot of money off of streaming. I wish I did. One day, maybe. It's out of the way. One day, maybe. But I think that would be pretty cool if we took one of these things and we put a giant tourbillon mechanism around it. Oh, I gotta tell Gonad about that. That's one to talk to Flatulent Gonad about, because we have this 3D model for a tourbillon mechanism, and if I scaled it up enough, this could be in the middle of it. That would be huge, but it would actually be pretty cool to have. It would be cool. It would be the size of like a kiddie pool, but it would be really... That's an interesting one. All right, anyway, thank you for joining me. I really appreciate you guys hanging out in the shop with me and doing all this weird stuff that we do, tolerating the slowness of some of these projects because we like to do actual engineering instead of just blowing stuff up. But we're going to work on burning the subs. We're going to get that running because we can get to the front page of Twitch with that. And you know, it may take us months, but I gotta hunker down and actually work on it. It's all starting to come into focus. We do LED stuff next that allows me to make some flashy lights in the shop, and then we'll roll that into more burn the subs stuff. So till then, have a good one, you guys. Be prolific, do cool stuff, and I will catch you on the Discord if you have anything cool to share.